Here we go. Hello, everyone. Welcome to the new time, which is actually UTC, same time as before. Oh no, I have blueberry everywhere on my hands. Look at this blueberry juice. Um, Welcome to the stream. Today, let me greet the people. Oh, why don't I see it on my docs? Okay, I need to update that ID. Here we go. Hello Tech, Taurus, Adam, Max, M40K, Lewis, Jordi, and not working, bitluni. Oh man, frustrating, isn't it, Lewis? However, Oh, Mr. Johnny, hello. I was on the Hackaday conference in Berlin, Hackaday Berlin, which gave me this t-shirt, and we were partying all night long. I'm still sleep deprived. I can't hear you. Oh, this is so sad. We need to fire bitluni. Yes, maybe. We should do it a different way. Should we hack it quickly? Like doing a TTS hack on the Raspberry Pi, but how do I add a user? How do I I need an extra user that basically is bitluni there. Okay. Let me talk about a little bit about the convention. I did like last Thursday. I had did quite some preparations. So we wanted to mill stuff. At the end, I printed the frame for soldering the LEDs, which is basically just one wall thickness of PLA now. And yeah, if you leave it on, like the pixel separation is way better now. Here, this is how it looks like. This is like the mini console. So whoever joined the first time or haven't been on for quite a while, yeah, way better contrast with that. There are some few things that I coded even on the. Oh yeah! Oh, I had the running text. It wasn't there before, huh? Yeah, it has like I just in the train I coded a little bit of menu. So we have like pink. There are two modes, blinking and non-blinking. Here, ooh, that's pink. Here we go. This is where the pink font went. Okay, and we have we can now return to the main menu as long as the loop, the program loop, returns false for some reason. Yeah, because we had like we're calling individual loop for each of the programs. Okay, this is, oh no, wait, no, wrong button, I mirrored. Okay, 5 is setting. That's basically just sound on, sound off. Because that was in the train, I needed like something sound. And we have something, wait, sequencer, where's the 6? Pink link. Pink link is new. Hello, René. Did I miss anyone? Okay. So pink link, let me. Oh, wait. Always pressing wrong button when I look. Okay, that's just. Oh no. Oh, that doesn't have. Oh yeah, it has. Wait. So that just reads the ADC of this LED. So it's a pink LED, and the idea was to get another one of the devices like this one, I hope we have. Oh no, that's not updated, I guess, because it has. No, it has. Okay, I don't know if it. Look at this. So we can basically read some sort of transfer between with just an ADC. No outside security except for the current limiting resistor. So we can use the LED also for sending. Yeah, that's the pink link. That's new on that mini console. So what are you talking about? Don't forget to advertise me. Yeah. And everybody, you need to join Johnny B's channel on Twitch to witness his 1,000 successful kills on what is it, Sniper Elite. And 10 gram noises intensifies. Yeah, it is. Okay. Food-wise, we have today some sort of pizza with thick crust, thick crust, which I don't like too much, but all right, that's what we have. Olives, some sugar-free booster, and some. This is some yeast-based dough cake that Tony made with blueberries and cheese or something. Yeah, no fondue for today. Sniper Elite 5, yeah, it is. Yeah, that's it. Yeah, mini consoles are cool. I had to fix something. So we didn't even have like an assembled version. Did we have an assembled version of that? Yeah. Wait, this one was the one that we made on stream. We didn't have pink link yet. Yeah, there is one issue if we run it like from batteries. I don't know why batteries matter. We need a flyback diode for the speaker, since I switched from push pull to only push, and that turned basically. So I was really struggling. I was finishing this up to take it with me to the convention to show it off a little bit, and then I used the batteries, and then every time I used the menu, it would turn off on the sound. I could hear like the first like beep, and then was gone. So apparently I didn't know what was happening. I thought batteries were low. They weren't. And then I thought, oh, wait a minute, I should try the flyback diode. So I botched them on. This one, since I'm using the face go away. Okay, since I'm using the surface mount buzzer here, I can use the footprint for the other through-hole speaker for the diode. So it has the flyback diode. That was one botch. And is there another botch? Oh yeah, I really had to put the switch on the other side. It still works the same, but it wouldn't fit with the frame. So if you want to use the frame, even with the LEDs, it was tight already. So I moved it to the other side, the switch. Doesn't really matter, it doesn't change anything. The battery case still fits next to it without like being exposed outside. Maybe with this hole now. So alpha version workable, but bitluni might work. So will it work? That's the question. It does sound. Current draw, I don't know. We can measure. I never measured current draw. I didn't have like AAA batteries ready for multiple devices, so I basically took them from any device that I had, I didn't run out on batteries in the weekend. I don't know. Let me get my meter. Okay. Bitluni works again, so we have TTS. But I can't hear you. I can hear only sounds. What's wrong? Oh yeah. Hello, Diego. Okay. We might be able. Let me switch on the camera. Boop. We might be able to use the current meter to check it. Wait, which one has a longer? Oh, I will just rip that off here, that battery case. It's glued with some sticky. Oh, there is one thing that I need to show you. Let me switch to the other view. Boop. Ha, here we go. So here, since we... Okay, enough of the fan spin. Okay. Enough. I can't concentrate. So, oh, another thing is, that's cool. If you glue this, if you glue the battery case like on, look at that. There is like this wire going across the thing. So if you want to glue it on exposed through hole pins, you have to be careful. So I took like this foamy double sticky tape, so really covered like all of that trash. Okay, let's measure the current. We have no, I didn't. Actually, this MCU is so robust. It just turned off when I penetrated it with negative voltage. So it's really robust. I couldn't manage to break one so far. Okay, AC. No, we want DC. 0. So we hold it next to the. This is very zoomed in here. Okay, you hold it next to it, or should we zero it out when it's turned off? Okay, yeah, we will zero it out when it's turned off. We just take one wire here. 0. Okay, here we go. So how many? Oh yeah, it's 14 milliamps. So how long will the triple A's last? Can anyone calculate that? If we use audio 50 milliamps. Oh, and also the screen is quite on. Okay, so we have probably something between 15 and 53. Yeah, that's 20. Okay, let's say regular current draw is between 20 and 55. Yeah, it will take less, but I want the brightness here. And I didn't test, actually, if it even runs on 3 volts. Never tested it. The MCU is specified for 3.3 volts. We can test it now, I guess. If it runs with at 3 volts, we will just bridge it here. Yeah, it runs at 3 volts. Oh, for foo. We don't need... Oh, shit. What? Even with audio. What? Oh, man. Oh, sorry. Yeah, let me put this. Can I squeeze it in between? Okay, like that. Okay, I want the current measurement. We can measure as well here. Okay, 0. Oh, that's 11 milliamp. That's 26. Here. 25. Okay, dudes, that's not bad. This is a test that I didn't even do before I planned this whole thing out. That's why I have this case with 3 batteries. But in future I can really work with with a coin battery even. But the coin battery, I don't know if it's able to provide enough current for audio then. We need like some sort of super cap or something and be really cautious with the sound. One thousand 1,200. So we have like, even with 60 hours with 60 hours at full power. Okay, that sounds reasonable. What are this one with? This one has, which one has any loops? Square LEDs are nice, but the pink ones are way better. If I can show you, where's the device? Where's the with the pink ones? Why is this so silent? I need more power here. More audio. Here we go. I will regret this decision. Where's the pink one? Oh yes. No. The pink one looks also nice, especially with the frame. I have like also a black frame for that. Let me check if it's upstairs. I'll be right back, and give me just a second. So don't run away. Don't turn off. BRB. Nein, jetzt hat sich mein Kopfhörer getrennt. Okay. I have no clue where it is. Probably my phone disconnected, so I need to reconnect to Discord again. Huh. Where is it? It's such a mess here in this room. Yeah. Headphones disconnected. Let me just reconnect myself. Okay. Because Discord somehow, when I reconnect my headphones, it doesn't switch the audio device again. Okay. No, I can't find it. It's not in here. My stash. Stashy stash stash. Huh. Oh, wait. Here. Oh, look at this. Oh, I didn't talk much about the convention yet, but this is funny. Okay. Yeah, that was the badge, which is a 4-bit computer. Here's the pink one. I still had it in this bag, my travel bag. Okay, here we go. Switch to that. I have now 2 of those badges here. From the SuperCon, there is like also an extension port. So it's a 4-bit computer that you can, there is like the complete opcodes. You can program it. You can store programs, run it. You can see the memory contents here, use it as a display. There are instructions as well. And a complete emulation of an ALU here, where you can see like step by step. Yeah, you can step by step use the clock or slow it really down to half a hertz. And maybe I can show this one off. Yeah, the batteries leaked on that one, so unfortunately I had to this is the SuperCon version and this is the Berlin version. So I didn't even turn the Berlin version on yet. I had my badge around my neck, the $1 computer. Okay, I found an envelope here. Needs a second battery. Where to run that? How do I lose all my batteries? I had like a stack of batteries. Oh, there should be one in this torch. Hey, Seth. Okay, a lot of rambling today before we start with the actual task. Okay, let me show. Maybe there is even like a program running that I written myself, or no. I have no. Wait, can I run it? Select. Oh, wait. Run. Oh no. I forgot how to use it. Program run. It does something, but I don't know what actually. I might need to change the. How do I change the page? Oh, it's such a long time, where I used it, but you can see something's blinking. The LU is calculating. Oh, now it's turned off. Oh, yeah, I had turned it off. So that's that. I don't know. I mean, it's a collectible. I can frame those, but I don't really need to actually. Still, that changed like the appearance a bit. So if it would be the same, like identical. Okay, see you then. Aaron, Christopher was also there with paper. He put like paper tags. This is one that can be used as a sender as well, and this one receives. And he just donated like a bunch, 300 of those, to the swag bags. And they were constantly updated with random messages like advertisement from Dave Darko or the timetable on the convention, so that was cool. And what he told me, what was really, really cool, that people actually tried to hack the mesh, because that worked like a mesh system. And there were like 5 or 6 people that tried to hack it. And he was really like, he really wanted someone to succeed, because it shouldn't be like super complicated. It's like, it's not like huge encryption or anything. Some gave up. I don't know if anyone succeeded. Hey Ray. Arturo was there. Since he's a Twitter addict, everyone got a blue check mark. And I just saw an L for loony, but the L was like a legasthenic L, which is mirrored. And oh yeah, this is the pink one. Look at this. Look at this. I only made the frame to solder the LEDs on straight. This is how it looks like. Here, this is how it looks like without the frame, and this is with the. So it looks like almost like a board. Yeah, and yeah. Oh yeah, this one can also wait. Let me do pink link. That can send. Let me do the receiving one, so I can show. Oh, you should on the TV. What country do you live that movie is already there, or is it are you watching it on your on your streaming system? Yeah, here you can see the blinks, but unfortunately I have like to. I'm still receiving. It has to be like really. Okay. I think we get like this white. This is because the LED is floating, and I think like a resistor. We could. Should we try it? Just put a pull down resistor like 1 mega ohm on there, so we see if it actually helps. Let me try 100K first. 100K pull down resistor on that. If it helps against the floatiness of when it's not receiving anything. So if it's not receiving enough current, it's just turning white. It's just floating. But why though? I don't get it. Or is it some kind of overflow? 256. I don't see, when I hold it against the screen, I don't see, it's not bright enough. Phew. Needs an OLED screen. Yeah. It has to be, apparently it seems to be. Okay. Let me put, where's ground? I just put it across and see what happens. Across the LED should be also fine. Because it's low side. Okay. We might need, for the pink link, we might need a botch. Okay. Oh, that's strange. Now it's like, look at this. It's yes, yeah. It's somehow it's like drifting up and down, and this is currently stuck at down and very low. I see something, but this is like barely noticeable. I don't know. Pink link has to be debugged. But that's not the reason why we are here today. That was just a short recap. Oh, yeah, I finally also met Bleeptrack in real life. Since we met on MakerCast before, it was like I was confused if we met or have met in real life before, but apparently it was the first time we had nice chats. So actually, Bleeptrack and we might want to go to the Evoke in summer. So whoever wants to join a demo scene party and do a product with us, we going to the Evoke, and this is something else. It's not the topic of today, but isn't it cute? That's the QFN version of this IC, of the same IC from the small thing. These arrived today. I have 30 of those, and I'll be giving them away because all 30 of those need a botch to be able to use USB if USB is available at some point. Yeah, yeah. I just took basic components. I didn't want to pay up the markup for pink, and I think even 04 or 202. This is like 0402. This is my world's first 0402 design. There are only limited components that the JLC have for assembly. This was completely assembled by JLC, and yeah, I programmed it. The bitbang USB isn't implemented yet, and I stupid idiot, I put one job, pull up resistor on the D- line. What did I do? Pull down resistor. Foo. And this is like one, I think the third from the right, the third resistor there, and the next here is 3.3 volts. So there needs a botch, and I need to like flip it to not touch the pad of the ground anymore. Stupid. Yeah. But it still works if you program it with the debugger on D1, and then you can use it for whatever you like. It's just a small dev board that receives power, makes 3.3 volts, and has a bunch of IOs on this super cheap ass mini thing. Yeah, that's that. I will probably just give them away because I can botch them or whatever. So that might be a Patreon gimmick. I don't know which tier yet. I have to check. I have to ask the people who wants one. If you meet me soon, you might get one of this rare version 0.1. Yeah. That's a possibility. So this is version 01. There are only 30 of those ever made, so it's a collectible. And yeah, I just have to hand them out. I don't want to botch 30 of those. I will botch one, and I might keep like up up to 2 because oh yeah, no, that's not OCD. That's like really the style. This is the style to have it like really across the device. So that's not I didn't mean to, but it's cool. It has even like, oh, look at this. So I will be back with being sponsored with JC because I need some quick assembly also, and quick and cheap assembly for production runs. Look at this. You can get it like on a panel, but then you have always some sort of whatever. Yeah, you should. Add, yeah. I was spamming Sion's stream yesterday with ads. So yeah, I might know it, but I don't know if I. Nah, no worries. I'm not even worried about doxing myself because who the F would drive out here and do whatever? It might be doxed. That's true. It's not like I want to live here forever, so I will think different if I like buy a house. But okay, second version doesn't have an LED anymore. I decided I want it as simple as it gets, and LED is basically too much. I went for the even cheaper converter. This one is capable of doing like half an amp LDO. The cheaper one is I think 200 milliamps only, but it's a basic part. And yeah, the BOM cost of that is, let me calculate, 14.20 probably, so 30, so like 40 cents maybe, without the PCB 50 cents. Unfortunately, there will be some taxes on top of that, but those might really sell like for $2 or $3. Bit blips. If you buy many of those, it will be even cheaper at some point. Yeah. That's the CH32V003. This is the QFN version. This is also the first time you see it on stream. Then, ladies and gentlemen, this is the first time I'm showing that on public. Here's the reveal. You see the laser marks. I don't know, compression probably swallows that one. Yeah, and this is let's take a look. Look at these connectors. Aren't they sweet? You're used to 0.1 inch. This is 0.1 inch. This is half that, so double the density. And it's 2 rows, supercluster 16. Each of the MCUs is connected yeah, 1.27. Each of those has an individual LED. So this is actually an LED matrix 4x4 already. Then let's take a look what we got there. Yeah, that has like a footprint of a CPU. It's 4x4 centimeters. Look at this, what we have here. So there is an 8-bit bus. Then we have a clock, a command, and this is the software debugger, the SWI. Yeah, I don't know why I called it I here. And it can run on 3 to 5 volts, whatever. We found out it can run on 3 volts as well. So the problem is, when I designed this, I didn't have even the dev board for this MCU. I didn't know anything about it. So I routed here because like you need the debug interface to program those. And I connected every single of the MCUs to this one line. I thought there will be some way in programming them one by one or all at once or whatever. I just went for it. Oh, and each of those is routing 5 GPIOs out. So we have like A to E and R. What is R? Reset. So the reset pin can be used for something else. What? The big one in the... What do you mean? What? 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 The big one in the... What? No. No spoilers. No spoilers. What is... What? No, there is nothing to show there. There is nothing to show there. No? Okay, so... So what I thought is, I routed out also the reset pin for each of those MCUs. And I thought, okay, if I basically hold reset down for all but one, if I hold down the reset for all but one, I can program that one. So I can pick an individual one to do whatever with that. Apparently, with this MCU, the debug interface works even if you reset. What? PCM? What is PCM? Top secret project. Docs. Docs, the secret, super secret project. So I might even release it quite soon. Okay. Yeah, apparently I can't use the reset. I can reconfigure the reset to be like an individual pin to do whatever. And I can use that one to have an outside controller just pointing at an individual MCU to tell it something, like select it or whatever, to connect to the bus or whatever. So that's the possibility. And so this is the supercluster, and this is the supercluster base, which has, oh, this is so many, like so dense connector. It's hard to get it off. I don't even plug it fully in. You can see it's not flush. The connectors are so good. I really love it. Okay, so here is the base. Also hand assembled. Oh yeah, this is both of those are hand assembled. Both work. So we have CH32V203. So a bigger one. No. It's not expansion port connectors. It's like basic connectors. I didn't print on the pinout of those, but that's basically a lot of GPIOs, which are like 5 GPIOs per MCU, and I think I even put something on there, like the bus might be also on there, and 2 different powers. So the board can select. This unfortunately has only like 5-volt tolerant pins on several pins, so I put like a resistor in between for the other pins, for the reset lines, and use them for stacking. Who knows? Oh, that jumper and that pink jumper. So better days. I somehow broke it. Nice pink one, huh? Let me replace that. Fortunately, with AliExpress, there might be enough jumpers available. So this is like the voltage selection for that thing. And since I want like to be able to use like a lot of current on each of the MCUs, and I have 16 MCUs, I have no clue about the power requirements. So I made even like the traces, the power traces, like I think 1 millimeter thick. So this is, oh yeah, that's also a 4-layer board. Should I will show you how that looks like. It's, you can see how many wires there are. Always there's like, and only few are like ground plane wires. This is like I showed this to you. I posted a picture of that one a while ago on Lab. This is also four layers. I think that one was 4 layers. Not sure. It could be, no. The other one is 4 layers. I think that one isn't in. Oh yeah, there is also a botch. Apparently, I don't know. You can see it because it's black. I couldn't drive one of the reset lines. I don't know, there is something missing. Oh yeah, this is also host and USB, which need to be coded. We can do graphics card here. There is some selection for the USB. What is this? Bus lines. I think you can pick something there. I'm not sure. Yeah, some molten connector here. I tried to reflow this one on top of that with the hot air gun, and my hot air gun is a little bit hot. So this is this one, small one. So with that on top, and this way around, that's sweet 16 RISC-V MCUs on top of another one, which, so it's 17. Oh, terrible number. It's even a prime. Okay. And, oh yeah, so for programming, you know what? I was able to program them all at once. So I made like a sophisticated program in the beginning that will rotate, like the reset pin was reconfigured in the firmware, and it would rotate between all the MCUs, and the MCU can turn off the debug port on its own. But Yeah, but there is like yeah, let me put that on. We can recode this. And then I was soldering one by one on and then programming them with individual IDs and whatnot. They have an individual ID, which we'll probably use in the code quite soon. But at some point I made a mistake and there is like a debrick mode, which even though I think the reset lines, yes, the reset lines were reset and it reprogrammed all at once, and somehow everything was broken that I did before. And then I tried just programming as if there is only one MCU attached, and they seem to be so much in sync that I was able to program all 16 MCUs with the programmer, even though the programmer asks at some point, are you finished with writing to the flash and so on. So there is some debug communication going on, checking the ID and whatnot. But apparently it still works to program all 16 with these two wires here. I can instantly reprogram them. And so I did the second one if we break one, and can reprogram that also at once, which is cool. Now I might show you something. What is this? What? Huh? What is this? What? What? Wait a second. There's a little bit more space in between. You can see. And you can put two on top of each other. Top of each other, and then you have a 4x8 matrix. But wait, what is this? What is this? Is this another connector? What is this connecting to? What's the labels? B04, B05. Is this another bus? Is this another bus system? Is this some sort of joke? Like, can you just take another one? Oh, version 2. What? Oh, what is this? That seems to match. That seems to match the footprint on the bottom. Wait, can you plug that in? And what is? Yeah. Oh, yeah. Funny story about that one. Oh, this is version 2 because. Yeah. That's a good one. Oh, this is my title for the mega cluster. So this is a 4-layer board. This is stupid. You don't know how many. This density of lines that are coming from the RISCs here, the density is on each of the layers. There is no space in between. The 0.2 millimeter spacing and traces. If I turn it around, it basically looks the same. Look at that. It probably has some diffraction grating quality already. Look at this huge board. This is stupid. This is stupid. Only like a few. This is. Oh yeah. Look at this. They're going up. These traces are going up. If there will be some crosstalk, and going over there, because on the inner 2 layers there are even more that are going here and there and there and there and everywhere. Yeah. So yeah, you can guess how many those are at the end. Yes, yes. Yeah, so this was before I ordered it. These are from JLC, the blades, because I figured, okay, this stencil here, this is ridiculous. Nobody will ever like purchase this humongous board. This board, like I think, how many did I buy? 2 or 3, 150 euros. What? And this blade, way less. So this is like way better to handle, and you can extend it as far as you need. So that's that. Oh, funny story about the blades, the connector, 49 positions times 2. So that sounds familiar, doesn't it? Who is from the 90s? That's the same count as an ISA port. That's the predecessor of PCI. And here, if you order from AliExpress and you order, let's say, connectors of different sizes, like these here, and they're all continuous, but yeah. But you don't read until the end of the listing, and you don't see that there is a gap. So the connector is longer than it should be, but you already bought like a ton of PCBs and designed them without the gap. The connectors you purchased might not fit. So I went on LCSC because there was no supplier. On LCSC, they had a 49 position connector without this gap on stock, and I couldn't like trust my eyes when I saw that this one is like available, and it's like affordable as well. It's like, I think $1 per connector or something, or $2. So it's not that expensive, like for such a huge project. And I was really happy that there is a bent pin. I need to remove it. Yeah, with 49 positions, a lot can happen here. So actually, no, I didn't buy them out. I didn't. This is so much money. I spent, you know how much. I posted it in Lab. Like, I spent $1,000 on AliExpress alone, like since the start of the year, just for these passion projects. Hey, electronics. So yeah, this could be cool. And since we can like stuff all the blades next to each other, we can actually make an LED matrix with those. But this is only version, okay, I don't spoil anymore. That's enough for today. We won't be even seeing like the mega cluster until like a few weeks. First, we need to start with the supercluster, which is already crazy. We don't even have a use case for that. Blade server. Yeah, these tiny things. I love it. I programmed a Blinky already on that one. Beep boop, beep boop, beep boop. But that's blue. They don't have much options on the 04 or 2. This is the one. Okay. Nice. So that was the intro. Now, 1 hour later, we can start the code. Shall we? Okay. So what do we? I need suggestions. What do we do with the supercluster? What do we? We can try. Yeah. Yeah. So, any suggestions what we should try? Okay, first of all, I mean, we need some groundwork to do for that. Where is the to-do list? Building phase. Here we go. Oh yeah, that's the mini game building phase. $1 console. Ha. Okay. Supercluster to do. Okay, here we go. Not the scroller. Make hardware. Okay, here we go. Hey, Aaron. Yeah, I have VGA programmed on that, on one of those. One of those can run, but only with external crystal. The internal oscillator isn't good enough. Wait, but they have a clock in from the one down there, which is way faster. That could be more precise. Doom. So one for the sound, one for the VGA, one for the game controller. What do we do with all the other? This is like the ray tracing engine or what? How do we even communicate? Okay, we need some sort of we need to make the bus work. Open bus. Okay, we need to do the bus work because I have no communication with the main CPU whatsoever yet. Then yeah, how do we hack? How do we hack? I mean, I can Cavera, but not like in one session. Open collector bus. So how do we? We should try a testcom. Okay, on communication. Okay, we need maybe a communication protocol because that's like they can talk to each other maybe. We need like a handshake because we don't know. Yes. Yeah, we can try that, but we can use it. Yeah, but the problem is I don't think it has a multiplier. It can add things quite quickly. We can make a lookup table. Oh, Mandelbrot. Okay. Charcoal. Communication. Test. We can check. Or you can find out. And that RISC-V has a multiplier. I mean, it's like 30 clocks then. Oh no, 60. Oh, you need to add. Shift, add, shift, add, shift, add. No, no floats. We do fixed point. I mean, we can still try. Yeah. Really? With portal engine? Okay, I increase the size of this. So we need to specify the protocol, then do the communication test. And then we need to somehow communicate to the... How do we communicate with the world? Oh, let's do a blink then. So we can blink a pattern. What else? But how do we do? I don't think we have enough time. Mandelbrot shader. No. No. That's the MCU. Close enough. No, 103 has a little bit more capabilities. Okay. How do we even identify the MCU? We have like... We have like an ID, but if I switch that... Okay, let's take a look how the open collector boss, if it's working or not. Spaghetti point? What is spaghetti point? Okay, I eat all the olives. Should I drink the olive juice? No. Kernel. Here we go. So the salty food is gone. Okay, mates. Let's check the capabilities of this MCU. Oh, I see the tweet. Had some likings that I posted before, where people could guess what it is. This thing here. CH32. Okay, so what do we have here? Oh, it's actually a 10-bit. I thought it was a 12-bit IDC. Okay, let me show the screen. Here we go. V2A interrupt nesting. Yeah, the RAM is a little bit short here. Yeah, nobody is interested in low power. It's low power anyways. Op-amp comparator. Oh, okay. 10-bit deck. So we have 16 ADCs on that PCB. It's way better than on any board that I ever built. But you know the crosstalk. A 64-bit chip unique ID, which is cool. That can be used for our identification of the individual MCUs. I'm wondering if we take the last byte of the ID and let each of the MCUs light up so we can maybe let the main CPU try to identify the MCUs. That's how do we use an open collector bus to let them not talk over each other? Okay, let's find out if it has a multiplier. So do we have a hardware multiplication? Hey Dave. Someone sells 5 pieces for $5. Rip off. Sub 10 cent? What is sub 10 cent on that one? That's not sub 10 cent. Nobody can get that MCU for sub. Okay. How do I identify what is a RISC-V RISC-V2A. Let's go to the RISC specification, RISC-V. The Wikipedia for that, Wikipedia was better. RISC. Which profile? EC. Okay. Where are the extensions? Where did I find the list of extensions? Should we just debug one and see how a multiplication looks like? Okay, let's check that. Oh, come on. Volume 2. Too much text? Okay, what do we have? Nah, this is too much text. We won't read here. Privileged, what is that? I found some page where I thought it was Wikipedia. Wait, am I on the? Oh yeah, I was on the wrong side. The German ones. Okay, here we go. So REC base integer instruction set 32 16 integers, and C is the extension. Where is this extension? Where is C? C, standard compressed instructions. EC, atomic instructions. Wait. And standard, what is, we need to find out what's in there. So compressed, it's not compressed, I think. Oh, we have here. So, no, this is not it. This is like easy compressed instructions. M, integer multiplication and division. Oh, you can see that. Sorry. So, no multiplication for us. It is only this here. And yeah, that's it. Multiplication is the M extension. And if it doesn't have M, then it doesn't have M. So no multiplication for us, apparently. Yeah, that would be that one. Use LED as a status. Yeah, that's what we want to do. So I think the best way will be to use MS Paint, how to use the open collector bus. If I'm wrong, then you need to correct me, because I have no clue for what I'm doing here. Your experts are working on that all your life, and I'm like a super noob that's just sitting here and eating all day. I must start recording as well. Okay, so we have like the boss lines. There's the boss. They have a pull-up resistor each. So any participant on that bus can pull it down. In an open collector mode, when you write, this is a 0, it's an active pull down like to ground. Drain? No. What's the opposite of collector? Emitter? Emitter and collector. This is the emitter. And collector is open, so there is no connection to VCC when we write a 1. That's done by this here. This will prevent that whenever like there is confusion on the bus, and let's say two participants, let's say here the host, oh, I want to write some, oh, you can see the host. Shit, it's too far to the, I zoom out. Here we go. So the host thinks, oh, I want to drive it up. And like this client says, I want to drive it down. Then you have, yeah. It might not be the best supercluster in the world, but it's a supercluster, and that still counts. Okay, however, when we have here open collector as well, well, basically this resistor will do all the work for pulling it high. And conflicts, ground is dominant, so it will be always 0. If a confusion is going on, but there will be no shorts. That's the plan. That's what I learned from the C64, I think. Wasn't that open collector as well? So we have like for each of the processors we have an individual reset line, except for one doesn't work, like the 15th doesn't work. So the host could Tom Matrix. What? The problem is number 15 in this design doesn't have like a proper connection. It's always high, so this is always one of the MCUs. But all of those have an individual ID, which is unique. What is an HPIB command? Why is your voice off? Did you turn off your voice? Did you pick a language that's not recognizable? I'm eating all the time. Still replenishing my body after the party last weekend in Berlin with all the peeps. Yeah, let me check. What is that? Hewlett-Packard interface bus. How does it work? Oh, okay. Yeah, do you have access to that document? Handshake. But how is this communicated? Wait. Oh, these are signal lines? We don't have that. We have a command line that I didn't test yet. I show you what we have. Okay. This is the bus, 5.1K pull up. Then we have here CMD and CLK. I need to check on which pins, because apparently it seems like I don't have access to some of the pins. To these here. D. No, wait, C? Wait, what? D? No. I should have access to these here. Not sure. Okay, command is on PB3. Okay, we have access to that. And then we have Oh, with I think this was, you can add a value, a pitch or something. Test. Your pitch might not be changed. Or your pitch was wrong. I don't know. Pitch, speed, oh. Yeah. Oh yeah, these are almonds and milk chocolate. That's so great. Okay. So we have like a comment and a clock line. But a clock line, wait, where's the clock line? Here. PB2. So we can use, I need more. I'm so addicted to these almonds. So I would suggest we do the following. We have the clock line will tell new data on the line. Let's use this. Okay. And it's always set by a host. I think they're also open collector. Let me check. Yes. Okay, they have also pull up. Okay, this will be the CLK. And whoever is the sender clocks out the data. So this is by sender. I don't know. It's not the main CPU. At some point there will not be a main CPU. So they have like to communicate. The handshake will be more complicated. Let me take the screenshot. Okay, here we go. Here. One. Yeah, steal my design. Yeah, this is already deprecated. And there is like this. So you see the pull-ups, and there is some more on the GPIOs here. So this one is, but not everything is. So these resets are direct lines to the MCUs, but not all of them are working. This one apparently I couldn't make work. It works on another dev board, but not on mine, and I don't know why. I have no clue. I couldn't find out. I tried for hours. So there must be a trick to configure the MCU to have on this, which are special. The PC is a little bit special. It doesn't have a lot current or whatever. Okay, however, comment will be is high, then if someone has something to say, we pull it low, then they pull it high on the first word again. No, wait. No. It should be done for the whole communication so we know someone is talking to us. No, it should be done on the first. And then we should listen to the clock. So the clock, okay, I need to redraw that. So the clock will be also high all the time, like that. And then will be some communication until it's done. Okay, so I think this might be the solution. How does the receiver know the communication is done? It has always to listen. I don't know. So this is start. Start. This is end. We might want to make USB serial working on that base computer because we don't have any extension card yet for that. So USB UART, I think there might be an example somewhere for that. Okay, so the communication will work like that. And each clock cycle there will be data. Data bits on the bus lines. And we send whatever this is. How do we shift it? LSB. LSB or MSB? What do you think? LSB, huh? This will be bus. Okay. Now, this will be how more or less the bus will work. Let's hope it works like that. And it can be taken over by someone. Oh, we need a bus collision. So, problem is with this distributed system, we never know. It could happen that two peers at the same time trying to talk, or two clients or whatever. So what do we do? Now we need a handshake. Hey Ray. So we need a handshake. I need. Okay, I can't draw anymore. I will use text because I don't have a pen here attached. Does anyone know a good program how I can use my tablet as an input device for the computer here? So, bus work, bus specs. Okay, bus specification. Sender pulls CMD low for one cycle. Now we have to test something. Sender sends its ID. Let's make it only like 1 byte ID, or I don't know. We have like, okay, we have the ID. Hey Seth. Okay, we are specifying the bus protocol. Sender sends its ID for 64 bits. It's unique. Sends its ID and listens if bus interrupted. If it's interrupted, someone else is sending. It will basically, in this first 64-bit, we will know if someone else is sending a different ID. So if we have like a collision at, listen here, I grabbed the bus, then we send the ID on the bus lines. And if someone pulls like a different ID at a different bit at the same time, which could happen, we will read the bus at the same time. I hope that works with Open Collector, that we can read the input while we are outputting something else. There are different registers for that, so we have to test that. I'm trying to get my head around this. We are talking on unicycle, bicycle, or tandem. That's like a tandem with 16 cyclists, and you need to like touch the pedals and see if someone else is cycling. Only one person is cycling at the same time, so you will just tap it with your feet and see, there is no pressure, someone else is trying. So what happens? Interrupted. Okay, so mismatch is with double S, yeah. No, it's one. If yes, so yes, wait for how many cycles? The other one should detect or not detect. Wait for clock to calm 2 cycles plus R&D. We have to shuffle a little bit on. Is there a better way? One wire interface. With 3 contacts. Oh, okay. So why 2 cycles? Because then we can see, okay, the other one stopped sending stuff. Should we receive and listen at the same time? So if the other one is like sending stuff to us, we don't miss it. So that's like different tasks. Okay. Wait. Okay. Yes. Wait for random clocks after bus calm. Calm means transmission, or means car not changing for more than 1 cycle. Okay, that's how we detect. Hey, no worries. You missed like the first hour was crazy madness. I was showing off some hardware, and so you can rewind. But this is what we are talking about now. The supercluster, which are basically 16 MCUs on a carrier board with another MCU that controls all of those, and they share a bus, a command line, and a clock line. So this is what we are working with. In future, this will be like the only thing. And each of those have a 10-bit ADC and 5 GPIOs that are routed to these extension ports. We can do whatever with them. Each of those have an individual LED. And the carrier has even USB host on top of the regular USB. Yeah, I did it by hand, but I have a few more of those boards, so I will probably set up my PNP, because that looks like a easy setup that can be done in half an hour and save a lot of PNP time, hand assembly time. Otherwise, I would need like to do like another 14 of those. The LEDs, they're from AliExpress, they're pink. They have a complete reel of those, because that's funded by Johnny Bechtel. Apparently, we have a pink LED fund. Where's my reel? Did I put it today? I lost it. It's somewhere here in this huge mess. My lab is unbearable. I was so stressed out last week with all the projects that are incoming. Once a video is ready, I will do a complete clean out here. Hey system. Oh, now we try to specify some sort of, you see that the to-do list here. We specified like open collector bus. What? More pink LED. Thank you, Johnny, for the donation. More. That's quite some pink LEDs. Where's the real? Where's the real? Okay, I have still like some of these here. And JLC, what I showed also before, I made this thing, and this is the first time I tried JLC with purple. Look at this, it looks also cute, but they don't have 04 or 2 pink LEDs at LCSC, so this is unfortunately a blue one. And look at this, I didn't penalize this PCB. It's 1.5 centimeters by 2.5 or something. And yeah, that could be, yeah, that's 2.5. Dark glasses. I used like, so with this one, underneath the JLC PCB assembly number, which still is visible here, this is the one, it's underneath this connector here, and I placed the assembly points for them, which are really tight on this PCB. They can also be underneath a connector, so you need to specify 2 assembly points, so they will be able like to pick and place this small individual PCBs. No panel, so I don't have like to shave anything off. Yeah, pink LED from, okay, I will give you the link. I will give you the link to the ones that I bought, because I have cool ones, and I ordered like 2 color LEDs, which oh, by the way, I have something cool coming. This is double color, but I can't really recommend the seller yet. They sent me one, so from a different seller I bought the 2 color with only 2 leads, which are basically different polarity then. Where's my order history? Oh, here. These look much better. I show you them. Yeah, here. With shipping. Wait, how much did I pay for this? No, wait. What did I buy here? Yes, 1,000 pieces, and this is the listing. Okay. Yeah. You can find the clear ones and the diffuse, even short pins. I think I even bought the short pins because that's even cheaper, a little bit. So 1,000 pieces, diffuse ones are, is this the right one? Yes. 11 euros, but shipping is 8 euros, which is a lot. Did I use another seller for those? So these arrived quite quickly, but the shipping is substantial, so you pay like 20 bucks for them in total. No, I don't think I used another seller for pink ones. This is the only one. Wait. Wait. Is this the same? I might have a different source for you. Diode, yellow. That one has also clear ones. They are all okay. Fog white, let me check. Yes, here. Are these 5 mm? Yeah. So I have both types here. Oh, that's not the right. That's not the affiliate link. Here's the affiliate link. I removed that. But you have my cookie anyways. Okay. Yeah, so these are like 100, and the 100 they come in this I think from this seller, and the big bag was from the other seller. I have also red ones. The square ones are from LCSC, and they look really crooked if you don't use like a frame for placing them. So with the frame, they look way better. And these are the pink ones with, yeah, it's oversaturated a little bit. They look really pinkish. Cool. Yeah, the milky diffused, especially if you want a display thingy, they're cool. Okay, back to our definition. So so if the read, okay, and listens if interrupted, if read write during the ID, we have a collision. Collision, okay. Then wait for random clock of after bus calm, because on collision we might still be able to receive something. So we have a packet, data packet, which is sender sends UID, then sender sends maybe then packet type, 1 byte, because at some point we might not know what other peers are on the bus. So how do we identify? Wait, every one of the peers could, like, on the start try to grab the bus at some point and just sends to all of them. So we have like ID, send receiver ID, receiver ID, receiver ID, 0 broadcast, and then packets type packet length, a payload size and payload. Okay, that's how it looks like. This is our hey system. Okay, so we have now a design. Oh shit, I'm recording this ramble all the time. Okay, so we have a packet that looks like that. So we have 8-byte UID, 8-byte. It's not very efficient, but because of the overhead, we might shorten the ID at some point. And do a basic collision detection. But let's optimize later. Start with the functionality first. Sender, receiver, ID. Then we have 1-byte type. Optionally, second byte X bytes. That's like Unicode if +1 if bit is high. That's like just bit number 7 is high. So bit 7, or let's say, so no confusion, if 8-bit or MSB have most significant bit high. And then ++. So we have potentially extendable specs here. Or should we send the size first? Packets should never be bigger than 256 bytes, because that's clogging our bus. So let's keep it short. One byte packet size including this byte. Even though it's a waste. So the UID, whatever, that doesn't count. So we have like another 16 bytes. But the packet type, since it's variable byte size, and maybe nah, let's not go that route. Yeah, we could do this the same here. I'm not sure yet. Okay, so this is packet start packet, and specs need to be clear. So okay, blah blah blah. So it will extend by next 7 bits and so on. You can do it. Joshua. Oh no. Okay. See you next time. You can rewatch. It might be boring at first, but I hope we can communicate something. Okay, let's define a few packets. packet packet 0 packet types packet 0 is hello. Description should be, or let's do more like that. Should we do a byte like of signing someone off? What kind of I don't know. Data. What kind of, we just need, do we even need a type? We just send data. I mean, the first one is addressed to everyone. I don't even know if, I'm not sure if we need like packet type. Does anyone have see a reason for having packet types? I mean, we could. Every MCU will have its own driver and know what it has to do with the data that it receives. So if receiver, if it's broadcast, oh no, it's a broadcast, then we need to know what type it is. Because we have we have more than hello for each broadcast. We could have something like turn LED on to everyone. Okay, let's leave it like that. Let's leave it like that. So let's keep everything under 128, so we don't have the extra bytes. We don't need to handle it. Data, raw data, raw. That's all we got right now. Okay, let's code it. Let's save that file. These are the specs. Where do I save it? Google Drive. And this is under code. RISC-V Supercluster. Specs. Bus specs. Okay, here we go. And oh yeah, I need to specify sender clocks data and transition on clock transition low to high, clock transition low to high, CMD. Oh, let's specify it. CLK is high when idle for longer than 1 clock. Okay. then circle low data prep, then low to high, wait, high low is prepare to receive, and then we have low to high as data valid. CMD high as idle or transmission going on if not idle. Okay, and then if this is stupid, just tell me. Low to high latch, that's how you call it. Okay, Jay, thanks. CMD high to low, low packets, no, transmission. This is like start, transmission start. Okay, this is crazy. I don't know, I'm reinventing the wheel, it seems. Request to send, clear to send, but they're like more than more lines. We have only one line to actually communicate at all. And that's like in all directions. You're doing the right thing with these notes like this. Yeah, I think it gets clear, more clear, each thing that I type, and then so we have like specification, what is a transmission? And this is basically transmission end, okay? So we know, okay, that's the same what's meant with what happens with the actual signals here. And this is like something else here. Bus specs and idle transmission going on, clock not idle. So we have something to identify what's happening on the clock. Then we have comment high low means transmission start. But clock should be low before that, I think. Should be? No. Okay. Transmission start. Wait. Yeah. Wait for CLK to go low and start receiving. Okay. Hello, yeah. Hello is our handshake. That means basically we can specify what hello means. Okay, so packet type hello will be like the handshake. Here I am. So since everyone is receiving the packets and listening all the time to the bus, everyone will see this one is sending, address is broadcast. We can stop listening if the broadcast, if the address, receiving address is not broadcast, broadcast. Broadcast. If the the receiving address is not broadcast, we can stop. Otherwise, if it's broadcast and we see the packet type hello, that means that every MCU at some point says, hello, here I am. And that's all. We can basically attach some data, maybe metadata, however that looks like. It could be even a JSON or something. We are reinventing I2C, yes, with eight lines. Bitbang one wire, nah, deal one wire, dal one wire, broadcast. Yeah, it's probably a reinvention of one wire interface with an extra data lines. Oh, need the dull one wire. Oh, I'm not knowledgeable in those things, so I reinvent things and then see it's one wire protocol. The debug protocol of these MCUs is funny. The one wire protocol is also like one clock is like a 1 and 2 clocks is like 0 or whatever. What are we doing? No worries. It's specifying a protocol for this thing. Okay, I show it. So the supercluster has 16 MCUs. It has a host down there. There is like another MCU underneath. I didn't stick it strongly on there. I can pull it off. So you can see the board underneath. And we have pull-ups on the bus lines and the command and the clock line. Oh, foo. And the clock is only the communication clock, not the actual clock. So each of the MCUs has a different clock since there is no crystal or anything. So this is the main one. It has a direct line to each of the MCUs. One isn't working. So the 16th isn't working. There is also a botch to pull it high constantly. For whatever reason, it doesn't work. And we have like, here are the pull-ups here's for command. Here in this corner, there is command and clock pull-ups. And these are the pull-ups for the 8 bus lines. Super simple thing. And this is the thing. Whoop. This is the cluster that doesn't even know multiplication, so I don't know what we will do with that. What purpose it has? Research, I would say. We can try something. Oh wait, yeah, we have an ADC, so we have 16 ADCs that can all get some data in here. Stop messing with the microphone. Uh-oh. And just HCS1, just weird, yeah. Yeah, it's 16 ADCs. That's one thing. And we have like 80 GPIOs. Since 5 times 16, yeah, 80. 80 GPIOs here that we can access over like edge connector cards. There are different versions that I showed before that have a few more GPIOs. This is the same MCU, but this is the 3 by 3 millimeter QFN version, also 20 pins. But there is no way you can put a via underneath of that if you don't put on like the ground pad that's needed. I even put like thermal vias, 2 thermal vias down there maybe. Sweet one. Loony to see. Sounds like lunatic, yeah. Did I drop out of the... Oh, wait a second. I'm not in TTS? What? How? What happened? Discord died. What is going on? Oh, shit. I missed the call. Oh, no. What is happening? Why don't I see? Where are my Discords? What is with this Discord here? Huh? I don't see any servers anymore. I need to agree to terms. Oh, come on. It kicked me out. Ah, that's why I can't listen. Okay, join muted. Here we go. And I'm wondering why I can't hear you anymore. No, it doesn't have any capabilities. The only thing that we can work with is the USB stuff down there. Anything that we want to add, we have to add over the GPIOs here, over the expansion card. We can add maybe some sort of VGA. It will be jittery because we don't have a crystal on there. Okay. Yeah, VGA will be hard without a proper clock. I tried it. The internal oscillator isn't that great. But yeah, we could use some sort of like this. I don't know. Useless. Useless thing. I'm wondering, we actually, no, we couldn't. Oh, yeah. Yeah, VREF will be VCC, basically. I think is there an internal reference? Don't we have information on that? Let me check if I have further information. There is a calibration method for the ADC. No, that's not it. What are you looking for? I have no clue. What does it say about... I have no clue. You check out Loony to Loony communications. Oh, crazy people. Okay, let me check. ADC, we have the data sheet here. Wait, this is the data sheet. Reference, this is not the reference manual. What is the okay, pinout specification. System architecture. So, wait a second. It here 2.7 volts. What? Oh, what? Ah, and the data sheet somewhere down there, it says 3.3 volts, but we can run it from a coin battery. Oh, foo. Okay, now that I see that, funny. Hey, Casper. Yeah, there is, wait, what do we have here? ADC. Oh, it doesn't show the ADC here. Clock tree, let me check. Clock. Voltage slope. There is a calibration method. Let me check that. Okay. Shares up to 8, blah, blah, blah. Provides analog watchdog, no monitoring. Channel signal voltage supports external event. Pin support DMA supports blah blah blah. No, it doesn't say anything here. But I can show you because I used the ADC already. Some maybe reference menu has some more specs. Where is the reference menu? Oh, chop. This will be the reference menu. Yeah. Nothing with this mini cluster should be critical. Okay, we can turn off actually the nom cam. We are done with eating. Here, capture for. No, I'm revealing the top chat. Here we go. ADC main features. Okay, ADC in, and then we have check to channel group, module sampling clock, channel configuration, calibration. Okay, self-calibration mode. A calibration session significantly reduces accuracy errors due to variations in internal capacitor banks. Okay, so it's only for linearity. It's on each capacitor. Oh, Casper, thank you. Yeah, the Tang Nano. That was a deep dive. If you ever managed like the PS RAM properly working on the Tang Nano, please poke me and tell me how, because I struggled with that for such a long time. I wasted probably 2 weeks just trying the PS RAM to work fast and properly. I don't know. I wanted it for the frame buffer somehow, but it wouldn't work. I had always some sort of bugs. But I will certainly go back and start with a fresh view on that again. The calibration, okay, Sampling time. Okay, there is nothing like a VREF or something. Forget about that. We can measure maybe if the battery runs low or anything, but how? We don't have a reference. Oh yes, we have a reference if we put a voltage divider. No, we can't. We can use it with a voltage divider. How do we? Oh yes, if we have like 3.3 volts and 5 volts, we can use that ADC even without voltage reference to check the relation between. No, the relation will be always the same. Wait. No, 3.3 volts. Ah, forget it. There's no way. Yeah, there is no pin for that. So we don't have any pins. Wait. Where's the we don't have even a pin for VREF. Wait, this is not the one. Oh, by the way, if you're interested how the 4-layer board looks like, so this 4 centimeter square, these are the 4 layers. I couldn't even put ground here except for the back layer. So dense. That's 0.2 millimeter lines. They're just crossing. So this is the. We can go one by one. Okay, this doesn't one. These are going this direction, and that direction. The biggest problem with that whole thing is that the what level shifts? What are you talking about? You're stuck on this ADC. Leave the ADC alone. We need to proceed with our stuff. It is already 10:30. I thought I think like the 80 mega has a 2.5. Yeah, there is a voltage reference. You sample actual separate reference. Yes, the Atmel have a internal reference of 2.5 volts. I didn't see that here. So if you see like wait, main functions, there is no VREF mentioned here. There is no VREF mentioned anywhere here. There is no VREF. Oh, you can see, wait. No VREF mentioned anywhere here. ADC sample RT whatever 24 megahertz maximum ADC clock. So we can sample at 12 megasamples. What? No. How many? Oh wait, it is least divided by 2 the clock. It should be fast then. We should check how fast we can sample. I did use on Tang Nano 9 PS-RAM as triple frame buffer for HTML. Little rework of their example for Tang Nano 4. Works fine. What? Did you use the IP blocks? Which IP block did you use? "75 megahertz clock." But then you couldn't like do like the full resolution because that's like half resolution of of 640 by 480. What's the clock of 640 by? I think the. Oh no, it's actually the wait, pixel clock is 25. Then you need maybe 16 bits. Ah, that could work. But not, yeah. 720p, yes, that's 75 megahertz. Oh, okay, interesting. Are you on the Discord, on my Discord? Can we talk like another time? Because I would really learn from his frame buffer IP. There is a frame buffer IP. What? And I was implementing that myself. Oh no. I used the PSRAM dual, whatever, because that's like not the actual dual port PSRAM or block RAM. You could only use one at a time, like write or read. And I tried to use that, like implement it myself, but I couldn't make it work. I had sometimes like what was it? Addressing issues or clock issues or whatever. So I need to check. Oh, maybe side trip. What's the, how is it the IDE called that we use there? I forgot how the IDE is. Go in. Yeah, go in. Okay, let me check. No, it's not the. Oh, what? Oh no, license ID. Ah. Okay, let me try the go in. It's not the go in community thing. I need to change this stupid IP MAC address. And unfortunately, I get to. Okay, I can check that right now. I will check another time. And see frame buffer IP. That will be easy then. Oh, that saves me a lot of time. Okay, thanks for the info. That was actually dual port RAM. Okay, peeps, let's code. Oh yeah, I wanted to show off the nice thing. Oh, the worst part about this, that you have like this huge footprint of this connector going across here, and you can put any vias over there, and you still need to put a bus across here and there. So if you this looks almost like a swastika, but it isn't. I did the swastika check. Now I get demonetized. Swastika check here for the bus, how it's routed. So it's going like that and that, but it doesn't do like stuff like that. I know that I changed some connections here to not look like a swastika. Synchro, what? Yeah, this is the crazy thing. This is stupid dense. Yeah, 0.2 millimeters. Okay. Okay, let's go. Yeah, I'm sorry. Yeah, you turned it off, the update. Yeah, I know. It's an Indian fire wheel. symbol, which goes the other direction, like I said. So something from Indian culture. Okay, let's code. Let's code. We have our specs here. Let's implement something. This is the blink for the bit blip. That's the bit blip blink, but we have different solutions here. Supercluster. Yeah, why does it ask me? Eclipse is so terrible. Obvious questions. Just switch it. Everything is saved. I can switch if I like. Okay, that's still switching. What does it do? Didn't I? Yes. Hey, live. What? I can't switch anymore. This project is unswitchable. Okay, let me open it manually. This is madness here. Okay, where is it? Code, RISC-V Supercluster. Now it opens. Now it opens. Moon River. Okay, here we go. So we have code for the supercluster and supercluster base. Some fancy stuff going on there already. I show you. So there is this method. Apparently this check that didn't work somehow. I check if the reset pin is reconfigured to data pin, so we can actually use it as a direct line between the host PC and all the peers, like the host MCU of this device. We can put this on screen here. This is our mini PC that should be always visible somewhere in the corner or something like that. Okay, and zoom in, enhance. Here we go. Yeah, now that it's small, I can plug it in. Beep, 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 beep. Now it's synchronous at the beginning, and you will see everyone has a different clock since it's already async already. Look at that. There will be it will be a complete chaos within a minute. This is how precise the clock is calibrated on them. There is no crystal, which is terrible idea for something that should run like VGA at some point. Oh, it already has some sort of mesmerizing. It looks like it's almost structured, but it's chaos. Okay. Yeah, that happens at the beginning. So I try to you have to, like, this is like a fuse, so you need to write to flash to disable the GPIO. It's doing something here. Blinking magic. Yes. Yes. So this is the code for the small ones, and we have okay, here. This is our timer interrupt. It's a system tick handler, which basically is called quite often. And then we can read, I think I have even, yeah, C. C should be our boss lines. So this is now mode in floating, and we should do we should do so what I did here is disable the debug and so on, but we don't need that anymore. And this is like the fast blinking and slow blinking. If this is enabled, like this, blah blah blah, we can throw it away. This is disable, enable. Okay. Indirect GPIOD 7. That's the reset pin. They're all active. So the host computer sends them all like you should be ready. So we yes, that's 32-bit MCU. So int will be also 32-bit. We call it different. This is like direct line. We call it direct line. So it's always on the, that's the bus. Then we need something like, this is the bus. Which line is, now we need to check on our, oh, I need to open the other one here, which is crazy. Okay, here you see how the configuration is. 150R, I think I even used like 200R. Or 100, I don't know. Okay, so CMD is, oh no, A1 and, oh, interesting. We could even clock the MCU with CIK. But then we have to rewrite everything. So actually we are using the pins here. Oh no. Who invented that? Oh, there's also D and E, which are RX and TX if you want to use that. So we have 16 UARTs on that, plus the ones of the main MCU. So D and E, these are all routed out. And A and B, there is timer interrupt, so we can PWM some LEDs or something, 80 LEDs of that one. And yeah, A4, A3, that's just the channels. So, and this is PA1 and 2. So we need another read cycle for that. Where's our Moon River? River Studio. Here we go. Floating. And we need AF, wait, I switched that. We enable everything, including A. So we enable A, and we need to floating, pull up, pull down. Now we will start with very passively. We don't let them send anything yet. Oh, I should Nah, we will check off anything when we are done programming it. Floating speed megahertz is still valid. Pin 7, that will be direct line. Direct line, then we have, what was CMD? CMD was 1 or 2? Wait. A1 is CLK, okay. CLK is, CLK will be 1. Wait, this belongs to that one here. Oh, what did I do? No, stop. Okay. Externally biased? Yeah, what? It's floating because it's an input for now. For now, the external pull-up, you didn't see maybe the schematic, is for the open collector. So I hope we can use the open collector reading and writing at the same time without changing the mode. So we have always pull-ups on clock commands and the bus lines here. This is the cluster base. We will start with floating there because we only want the main CPU to talk right now, and we will try to see if we can make them do whatever the main CPU wants them to do. So we check, okay, open collector from the main CPU only does something. We can even shouldn't assign inputs as floating if not design requirement. What do you mean? I don't know. I'm currently just setting it up so we can see at floating. Yeah, we just, oh, you know what? We leave it because it's the same for all lines, I think, even the direct line. Open collector since, yeah, this will be all, and this is GPIO2, which is CMD. Oh yeah, you mean we can check. Okay, let me check. If there is, yeah, it's mode IPD. What is IPD? In floating, A in, so analog in. Alternate function OD is open drain. Alternate function push pull. IPD, IPU, I have no clue, I forgot. Mode out, open drain, push pull. Oh, yes. Internal, but it's push pull, internal pull down, pull up is input. Yeah, so this is in floating, in push down, in pull up. That's the modes here. So it has both push up, push down, whatever. So we didn't necessarily need like the external pull-ups, but you don't know how many peers you got on that line. So we get like stronger and stronger pull-ups. Although these devices are actually similar to... What will fry the device? No, I don't. Oh, I don't know. Maybe the 50 megahertz is slope rate or something. I don't. The strength. Yeah. Okay. Let's do floating for now. So we will have only receiving side on the MCUs, and we will do. What? Why? You mean because... But it's not. Actually, there is a pull-up. So it's not really floating. But why? I mean, if you have a CPU and a pin isn't connected, it's by default floating. That's like the basic configuration, floating. So, and there are clamp diodes so that's like, there are clamp... What? That's complete news to me. I don't know. I have to check. Wait, can be biased. Interesting. Okay. However, we have a non-floating external pull-up, 5K, 5.1K external pull-up on these lines. So nothing is frying so far. And this MCU is very robust. We dealt Sean with like flyback negative voltage on those pins, and it just turns off. Ah. Oh, interesting. Okay, I have to read this up. This is interesting. Note to myself. How do I? Okay. Now let's concentrate on coding and not the hardware. It won't oscillate. It's not floating. Stop. Stop now. You're obsessed. There is nothing floating. There is an external pull-up resistor. Nothing is floating there. Okay. Here we go. That's the bus lines. So bus. Yeah, you really odd. Okay, here we go. So we have the bus, which is C. Then we have direct line. Then maybe we should use like bus like constant direct line. I use it like that. Oh no, let's leave it small. Bus. Then we have and CMD, CLK, CMD equals GPIOA in driver indirection. And we will check for, I have no clue how we'll implement this. Really. This is mad. I have no clue how to implement this right now. Okay. This is not needed anymore. This is not direct line. This is for the blinking, but this is really not needed also. That was needed when we needed like a separated programming interface. Okay, this is our cool. So we have CMD. We have some state. State int bus state. Bus state is 0. Const int bus state is a state machine. Bus state, which one? 0 is idle. Const int bus state prepare, and then const int bus state receive. And then const, and yeah, we need to define it. So this is 0. It's 1 bus state receive, and then send. And then, oh, this is pre-receive, and then pre-send. So we have state. What? Power up? What is that? Okay, receive, state receive. Let's do 2 and 3 and 4 and 5. Oh yeah. That's what error does. Glitching. Then we need and last. We can do that in like static variables. Okay. CMD. Wait. Bool. Oh, that's C. Ooh. I hate it. Okay. Let's do it like that then. 2, yes. And CLK. Okay. We need to oversample. I don't know how fast we can use the bus. We will try to use it as fast as possible, but we need to optimize it later. For now, we will just take two samples to do the clocking. We could actually maybe, do we have a comparator? Like we could implement this in hardware as a hardware interrupt on CLK here. What is op? No. Operational amplifier compare time. I think we can do on each pin, we can do some sort of interrupt. So since we have always clock running, it might be, yeah, we might get this in hardware, but let's do it in software first. This is comments, yeah, okay. So FMD, if not CMD, then it starts. Start receive. Oh, good night, Max. Low noise bus. RISC data. What is this? Oh yes, you're right. Shift right. Ah, well spotted. Well spotted. Bus state is now pre-receive, since we not sending. I think we not sending. Wait, we should separate this. We should do everything on a different bit. 4, 8. Okay, let's do. For whatever reason, we split this as well, but okay. Pre-receive. And then last CMD static last CMD. No, wait. We have it in the state. So, and bus state. Or should we do it like that? If bus state idle, then do the following, and then we start with, if we are an idle and we get comment down, then bus state, it's waiting on clock. We need to wait on clock to be done first. Oh, we need to, if not comment, and and not clock, then we switch to the state. It indicates that's in our specs. We need to wait for the clock to go down. Comment is idle for transmission, not idle. Comment high low transmission start, wait for clock to go low and start receiving. Okay, so we need to, no, actually it's not true. We need to go there. If not comment, okay, then in an actor fed by, you have an expert talk. That's cool. Okay, so if we prepared wait. If not CLK, then bus state is receive. Data. Bus data, and this is in char whatever. Yeah, that's not known or what. Oh, int. Oh, wait, here. There we go. Yeah. What did we say? 128 plus 8. No, 256. Whatever. Some sort of, no, plus 8 plus 8. That's the size of, yes. Okay. We could do even a struct there. I'm currently like really brute force. Bus state pre-receive, and then we have those names tell me nothing. So you need to explain what is happening there. Like what's the key feature for the bus? It looks like you want one of those devices and try your luck with coding it, like bringing the best bus. A challenge. Implement the best bus. Fastest transmission speed wins, or more consistent, or whatever. What are the things that we can test for if we do a challenge? This could be really cool. I mean, oh, the mic is quite up there. Sorry. This could be really cool if I make this an actual. Oh, this mic is dying already. Let me switch before it dies. Here we go. Nice. No audio loss this time. Okay, here we go. So imagine this happens to be a product. Aircraft comms, okay. Wow, yeah, in the 80s here with this MCU. But it's like an Atari, so. Okay, bus receive state. Then we have int bus data index equals 0. Okay, so and now we need to receive wait for the transmission to begin again. It's interesting. When do we start to interpret the data? I mean, we could know like from the data packet that we received the message already. So let's say if we have like okay, if we are receiving, okay, this is going on like it could happen. No, it couldn't happen all at the same time. So the next one is like if last CL key. Okay, so last CLK equals CLK, and this will be static. Static and last CLK. And then we have static. We need to count the idle CLKs as well. And CLK idle equal. So now we have if CLK, then we have a new bit. And also, so new bit received. Okay, new bit received. And also if not CLK, then it's not idle anymore. So else CLK idle 0, and we have like a threshold where we terminate the communication. CLK okay. Okay, look at this. This is nice. This is nice. We got already like the implementation of idle, and we have like a const int bus CLK idle max. And let's say if the clock remains for how many 4 clock cycles low, then we have like an idle high, then we have an idle bus. So if we receive, we have like this will be the first clock. Does it count already here or on 4th clock? So if we do it like here, if we are still idle, yeah, let's do it like that. CLK idle equals else increase. Okay, so we exceeded the idle max, then we have bus state idle. bus state idle. Okay, so there could be also bus state idle if we, oops, not equal, if we received all the bytes. So this is semantically, we can terminate semantically or on hardware level, like here state machine level and semantics, because we know how much bytes we want to receive. Now we need also the bit index. Wow, this is crazy. Peeps, data bus byte bit. Okay, by data byte bit index. Okay, cool. What a mess, what a mess, what a mess. Oh, tech. Good night. I hope we can make the bus running today and I can set the LEDs and yeah. I feel you, my friend. I'm also quite tired, but now I'm keen to implement the bus, so I can do a video and show they're able to communicate at least their IDs. It will be funny. Okay, here we go. So, new bit received. Wait, oh, we have a parallel bus. Oh, I'm stupid. Oh, we have an 8-bit parallel bus. Oh, this is so cool. We can, I don't need that. Oh, nobody said anything. Oh, come on. We receive whole bytes. Nice. Nice. Oh, cool. Okay, bus. So, new byte, my friends. Bitluni. Good night. Okay, so bus data bus data index plus equals bus data. Let's call it bus data. So it's more clear. Wait. No, this is already yeah, food this. Let's call it just bus. Sorry for the confusion. Is this, should I, is there a way to change this font size? Okay, so there is only one master, but in the next version, I can tell you already, there will be no master. So they will negotiate everything by themselves. However that works, I have no idea. This will be madness. There has to be some sort of... Oh, yes. So, Packet error connection. No packet error correction. It will be all false. Okay, so each of the MCUs has a unique ID. Okay? So we can deal with that. Okay. You throw all these abbreviations on me, and at the end of the stream, I can't remember a single one of those. You can maybe explain a little bit, like rough explanation how that works, CD SMA, and then I will rather remember what's going on there, or have it as a basic idea. Okay, if both data index, if we have received, how big is our specs? Packet size, VDIM, one wire has protocol where anyone and the boss can start transmit. I don't know, Casper. Synchronic the C7. Okay, so we have 8 potentially. Okay, you know what? F this. This is like maybe for packet bytes. You know what? Food is. We don't need this. We keep it simple. We just do this, okay? So we need to receive 18 bytes, okay? So if we have received enough data to start any transmission, unit discovery, we have that specified. Did you not listen? This is how that discovery happens. So here there is a hello packet with metadata. Everyone will broadcast. So we have like the sender unique ID, receiver unique ID. If the receiver unique ID is 0, then we have a broadcast, and then anyone on the bus will try, once it's powered up, send a hello packet. Yeah. Yeah, I have also an imprint of an at Mega Nano. So every one of them on power up will send a hello packet. So it will broadcast its unique ID. Yeah. So it will broadcast by just starting the packet. It will already broadcast its sender UID, so it is discoverable, and then it will broadcast it, so it will send 0, so it doesn't need to know if there's someone else listening. Then it will send like a simple packet, which is a hello with metadata. So it can say, oh, here I have VGA card attached, or bus collision is handled here. If you can read properly, you need to read. So sender pulls command low for 1 cycle. Sender sends its UID, and so it sees if command is not low. So it needs to be, the bus needs to be idle. So clock is idle and comment is high. So that means bus is free. It pulls comment low, but at the same time, there could be a collision where two see, oh, the bus is free, I need to send right now. So both pull it. Wait a second. Let me explain. This is smart beyond your imagination, it seems, because look at this. We have a collision at the beginning. We have a collision, and since both pull the CMD low, and they think I own the bus from now on, because everyone else on the bus will start listening. Oh, some communication is coming up, and then let's assume we have a collision of two or more senders. No. This is I will draw it. This is crazy. Okay, I start recording because this is smart. This is smart. I show you what I have imagined. Okay, here imagine we have yes, beyond my own imagination. Okay, so we have the command line CMD. Okay, and let's assume CLK is idle. CLK is idle, that's high, and CMD is idle. And then let's say we have peer 0 and peer 1 at the same time here decide, oh, I want, this is their CMD, they pull low here. At the same time, this one pulls low and this one pulls low. And they think I own the bus. From now on, let's say different peers will start listening because they didn't want, they already broadcasted or whatever, they're just behind or whatever. Let's erase that. There was wrong window. I wanted to erase in OBS. Okay, here we go. And then they start to send their ID, and the ID at the same time they are listening to the port, to the data, and receiving at the same time. So they send, let's say, they have both a unique ID, and the one has, let's say, 255 unique ID, 255 that puts on the bus, and this one has also 255. They're from the same batch. 255, 255, and they both look at the first byte at the same time. They read the bus as well and see, okay, since this is open collector, so everyone can pull down the bus, but no one can pull it up. Only the pull-up resistor can pull it up. So if the data matches, they are still clear. They say, oh no, that's all right with me. Yes. Not with the lowest ID, because it's 8 bits. So if there is like a, I give you a different, so the next byte of the UID, we have like an 8-byte UID. Let's say this one has 128, that's inverted, and this one has 2. So that one pulls another bit down. let's say that one pulls this bit down, and that one pulls this bit down, and both read, this is what the data reads like combined. It will look like this. And both of them will see, oh shit, there is a collision. I'm not the only one. And this is what happens next. So both have a collision. They scream abort mission. And this is what happens next. So if read is unequal to write, ID mismatch, yeah, parallel to an extent, because yeah, you know, it could be that like there are some constellations that win and lose and whatnot. But you are right, it's not equally distributed. So there is a winner. There will be some survival of the fittest. Okay, and this is what happens next. Look at this. Look at this. Collision. And we don't need that yes, because otherwise it will wait for random clocks after boss calm again. So CLK not changing. So if it's like after bus idle. Okay. So what happens after that? Oh, okay, Jay. Good luck. But we are done. Okay, so after that both cancel. Bus is free. And one will start to send here, and the other one will start later, because they have a random, somewhat random. The seed could be the unique ID. So yeah, we can use this the unique ID as the seed, and they have like a random shift when they start to sending again. Otherwise, we might have collision after collision after collision after collision. We don't want that. But as you can see, they're not blinking like at the same time. I think it's never perfectly calibrated, since they don't share one clock. Is there an offset? I can't tell. That's so fast. So this is how we prevent collisions, and this is how they can negotiate whatever communication they are doing. Currently, we are implementing just one master that's sending to all of them, and they're just listening. So we are just implementing the receiving part. Tends to trust. Okay. Okay, so we have a working bus. At least I assume. We will see if there is like stuff happening. I call it the loony bus. Yeah. This is just the receiving side. And the sending side will happen at the same time. And I hope with this open collector, the design of this is one thing that we need to clarify, is GPIO, that we have independent read and write. Why don't I see the chat updating? Keep going. Okay, GPIO. So we have write IO pin, you see that output driver, the PMOS, this is the push-pull, open drain or disabled. So an open drain, that PMOS will be turned off. Oh shit, I need to move it further to the left so you can see more. So this is how a GPIO works. These are the clamp diodes that I told you. So if there's something going on, I will just turn off. Whatever. So this is the output driver. What did you mean with the floating? If it's floating, these drivers are basically open. Then we have here push, pull up, pull down is open. The only thing, we have this TTL Smith trigger. Good night, Dave. Bye-bye. We have analog input here, alternate function input. So there is only a TTL Schmidt trigger. I don't know how the Schmidt trigger works, but input data register. Okay, so we have an independent, this input data register is independent from the output data register. So what we write is not yeah, but what breaks? Okay, maybe you can explain now which part is that you think that, oh shit, that was middle mouse button. I'm too used to, which part of that breaks? What happens if I let it float? So this is open, this is open, this is disconnected. What happens here? The Schmidt trigger, is this the Schmidt trigger? I mean, there will be always, if nothing is connected here anyways, there will be some leakage currents to ground or to VDD. And it will always end up like oscillating or whatever towards ground and VDD or not. Do I get it wrong? Or do you have like some kind inductance going on and the voltage like oscillating off scale and pumping, or what is happening that you think it will kill itself? Also, there is this protection diode. So okay, look at this. We have a protection diode anyways. So if we have some sort on that floating, some sort of inductive, whatever, charge, pump charge, the voltage doubler, hocus pocus going on, at some point the protection diode will basically drain any thing that goes above VDD or below VSS. Ah, okay. Oh, nothing's okay. No. Okay, interesting. There's something new I learned today. However, we are now sure that output and input are independent. There are also different registers in here. So we could actually check oh, so transition you think we will get like a race condition, or what happens then? Race condition and it shorts internally, but the Schmidt trigger prevents that or not? What's the Schmidt trigger? We're learning stuff today, so maybe we can elevate more than just me today. Schmidt trigger, okay. So input modulates, what does that mean? Let's read it in English, please. Smith trigger. Okay, so Smith oh, yeah. Yeah. Oh, this is behind. Foo. This clipped. Okay, here you go. This is how it looks like. I think this image says it all. This is hysteresis. Yeah, hysteresis for here. This is how the input output looks like. Okay, so no worries. Okay, so we are safe. We are safe with leaving it floating. It will basically happen something like that. Beep boop, beep boop, beep boop. Yeah, okay. Now let's do some. Yes, I'm still in the FPGA land. Hey, Konstantin. Wait, did you? You just revealed yourself from the off. Okay, let's finish our receiving side. We receive more than 18 bytes. So we know the type of thing, whatever, and we can just end the package. Ah, you're great. Where did you spot? Yeah, you're just teasing me all the time. Yeah. I think this MCU is so robust. I fed it like with negative voltage from flyback of a magnetic buzzer, and it just turned off and turned on again, and no pin is broken, nothing. On the ESP32, the deck will break if I just short it for a short amount of time. I have so many ESP32s with broken deck pins. First function mentioned. Yeah, you're still about floating? Give us a break. Okay. I just canceled the transmission after the bus state is idle. Oh, wait. We need another state. The bus state is not idle. The bus state is not idle. The bus state is... Oh, yeah. Let's put a new bus... This is confusing. Okay. Bus state... I don't know. and then only idle will appear after... Hey, MK. Can we ask GPT to design a bus protocol? Okay. Okay. Okay, we ensure once we canceled the sender by ignoring anything that's coming after 18 bytes, we just go into bus state I don't know, because we're not sure if it's still clocking in something. And basically after clock idle, this is for sure, if we have clock idle for certain cycles, we then know bus state idle, okay? This is, and when bus state is idle, we can still, okay, I don't know if this is crazy confusing. We should maybe define you know what? I should do like a void let int on, and then do the blinky blink. Okay, so GPI, yeah, set and clear. Okay, here we go. If on, then we set else okay, here we go, clear. So let on off, and we should make it like, we should just take a look at the type of packet. Okay, so we set like, okay, if it's 0, then the LED is off. If it's 1, then it will go on. We'll just do like that. Okay, so we take a look at bus. This is, it's bus data, and we have 7, 8. No, 8 bus. No, wait, this is length type 9. Okay. Wait, no. 18, 16, I'm confused. 16, 17. 17th byte will be sent to LED, okay? We're just sending the packets. Okay, so this is only the receiving side. What's yeah, okay, let's compile it. Direct line is not, last CLK. Oh, not used, because we need to set it. Wait. Huh? Oh, wait. We need to check for last, for the transition. FCLK. Oh, yes, here. This is the transition. So if CLK and last CLK and not last CLK, this is a stupid C. That could be like, that could like not work. I need to convert to C++, then it will be clear. Okay, this should work. I hope it works, but because you can never know. Okay, direct line is not used yet, but okay, let's just. Okay. Should we program it? It will go off. It will just go off. Or should we code the base first, okay? Oh, wait a second. Let's do an intermediate step so we know that the clock is even working. We can still overwrite it later. So we just see that something's happening on the clock, okay? See, it should be on constantly if we have no code whatsoever on the bus, okay? Here we go. Now let me connect the programmer, which is very simple. These are the just ground and this one wire interface here. And this is how we program all the devices at once. Bam! Okay, so our clock line is high all the time. So it should detect that it's idle. And now we move this programming interface to here. I know it. Here, so we can program the other device, the host. So look at this. This is now constantly on. So you see that we're not cheating. We programmed with one programming stroke. We programmed them all at once without verification, nothing. We just threw it on there and hoped it worked. Download and verify success. I don't know which one answered because this one wire was blocked, but actually the implementation accepted like the first response. So we are fine. We are fine. Once the flash wears out and they are not as fast, like everyone as fast as the other ones, that might change, but currently we are able to program them all at once. At some point we will send packets with firmware updates, but currently we are just happy if the LED blinks. Okay, so supercluster base. This is this code, huh? Yes. Okay, so we have here the reset bank and the reset pin, and we have no bus whatsoever. Where's the bus? Where's the bus of this? Let's check on which port we have the bus. Bus is on PB. Oh, shit. What is that? PB8, so we have even to shift it every time. Okay, this CPU is faster, but it will be easy. I hope we'll be able to brick everything at once. Okay, bus PB9. Okay, PB8. Everything starts at PB8. So yeah, these are all enabled. I should just enable. Oh, we have the bus enabled already. This is sweet. Okay, bus is enabled. Oh yeah, I used it to address them already. Okay, so let's do a transmission. This tick handler is very slow, okay? Very, very slow. This is reset bank. That's rotating through the banks. Okay, out the RPB bus time. Okay, let's do it like this. Oh, what's the clock? What is the clock? We should just start with the clock. Okay, that sends just a timer. Yeah, I don't care about that. I would just remove the code. PB out the air. What? I don't care about this whole contraption here. We will just send. What can go wrong? Where's our clock? CMD is PB3. Oh, nice, PB3. So let's open that up. You know, we could also do something like, yeah, let's not do the 4. Okay, whatever. structure. We can all write with one. I think I even designed it like that. So that B and with on register write, we have everything on the line, so we can clock the data. Should we even? Yeah, we should. We hope that. Oh, we should make sure that in the other one we read comment first and then the bus. If there is some sort of that we don't get. Yeah, okay. This is important. We can fix that later. So next time we program, we will have the right order. If we use like one register write, the clock and the data could be at the same time, and we want like to read the clock first on the small MCUs and then read the data. So we have some time for the transition. I have an oscilloscope with 16 input channels. 6 input channels, but we'll do it live. We will do it live, okay? There's no need to be worried. That will work first try, okay? PB3, so we have, what was this, CMD? 3 is CMD. And CLK PB2. Oh, this is so sweet. Read the clock not using it. Not for now, because I never use the clock, this will be perfect once we make an external interrupt like GPIO triggered clock. So we can clock in the data like really precise and not wasting any polling time or whatever we're trying there, okay? This will be awesome. CLK, okay? Pin 2, pin 3, and now we just need 8. Or, you know what? We just sent, oh, no. We don't know what else on the B bus is. Or, time and 1. CLK was 2. Or CMD is 3. CMD is 0. Let's leave it like that. CMD. We should see the LEDs blinking in some way, some sort. Are they push-pull? Oi. Dangerous. We might as well short it. Is this all push-pull? Yeah. Oh, shit. That's why the other ones are floating. Okay, let's see. Open collector, open drain. Wait. Open drain. Did I do a boo-boo there? Which one? Which one is drain? Okay, Casper's, have fun tomorrow. Did I just? Wait, which one is? Wait. Which one is? Which one is the collector and which one is the drain? I'm always so confused. Okay, so open drain means we need a pull up, huh? Is this right? We will find out. Okay, bars plus the 2 lines and mode pull up. Yeah, this is something else. This. Wait. Okay, that's what I wanted to know. Okay, that should work. That should work. Okay, let's see. Let's see. Yes! Yes, very slow clock. Very slow clock. Is it clocking? No. It's done. What? No. No. Nothing happening. Shit. Let me reset. Yeah. It takes a while and then it turns on. Clock. Okay, let me try. Push pull. See if that it shouldn't break because we have only one that's pushing pulling. Nope. Do we have a bug? I need to check. The. Oh, we can test the bus lines even with simple multimeter. Oh, or an LED. I found an LED on the floor. We have the clock and we can check the clock if the clock is doing anything. Don't even need. Where's the? This is not the one. I should switch it to open collector again because I don't want smoke escaping from that unit. Open drain, whatever they want. Drain, collector, drain. Yeah, that's all the same. Here we go. Okay. So which connector? Which connector? So we have bus. Clock is third. third one is clock. And we have ground here. Oh, that's easy. I just put the LED here in between those two legs, and then there is something going on. There is some blinking. Oh, I know what happens. That clock is way too fast. No, it's not. It's super slow. What? What is that? CMP, what's the count? This is no good. Was this even B? Yes. Drive. Clock time and 1 time plus. Oh, good night, Fruchti. Are really board chip error? What? That one didn't like something. Board chip status error. Uh-oh. We might have fried it. What? What's going on? Status. Oh, this pin might be loose. Yeah, pin was loose. Okay, let me try again. What? I don't know if this is flickering or not. How fast is this running? Oh, very slow. Wait, did it ever leave that? That just stays on. It turns on and stays on. Why though? Tick handler. Did I break anything? Yeah, no. I need to check it. Yeah, if it's not 3.3 volt, if it's not 3.3 volts, then I can certainly say it's with open collect, open drain. 2.5. No, this should be fine. 2.5 should be fine, DC. It's constantly on for whatever reason. Let me set this to null, and see if we have a different, if it's pulled down all the time. Yes. Okay, it never turns on. So it turns on but never off. Time and 1. It's never returning here. What is going on? We can debug it. You know what? Ha! Since we have only one, there is only one. Maybe the system tick is way too rare or something. Let's let's debug it. So this debugger worky work, okay. It enters this again. What? Okay, 10. 9, 5. 9, 7. Why is time increased twice? 9, 9. What's going on? Oh, time plus plus and time plus plus. Oh, good. Nobody spotted that one. Shoot. Yeah, we incremented it here and there. That's why always odd. And if we ended with 1, okay, here we go. This is your blinky blink now. Oops. Sweet. Okay, debugging helps sometime. Okay, this is funny because now this clock is way slower than this clock. Okay, let's slow this clock down to 1/16. You want a bigger image here, huh? Okay, here we go. Let me program it. Okay, here we go. This is our clock line. It's clocking in. And now we need to implement a transmission. Okay. This one looks a little bit off. This one here. Super shippable, yes. Oh man. I mean, there will be people who certainly would nerd off on that thing. I'm sure this is already cool. Let me think what's next. Okay, let's do a transmission. We still need, like, I mean, we need to set the clocks. I have no clue how fast the other ones are polling, because we need to check. It needs to be faster than this here, at least 2 times or 3 times. And if we start at 48 megahertz and that one starts at 144, so this value here needs to be whatever, higher, lower, whatever, for the communication to work. We can specify that. So times 3 or times 4. We can use times 4, and then we need to set the max for the idle clock idle. We need to set that high enough. Oh yeah, okay. We might have one as well quite soon. Or is this some kind? This looks like one of the supercomputers in IT crowd, where this what's the guy's name? This Goff guy sitting there, blinks and blinks. Here we go. Okay, I'm happy. I'm happy. Oh shit, it's so late already. Okay, let's finish. Let's finish at least one part. It's one part. Uh, let's start a transmission. Oh shit. Should we clone that stuff here? It looks like I need a header. Oops. Okay. Pop, pop, pop. This is the attribute. Okay, here we go. This is our data. And we want a transmission. So tup, 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 tup. This is something that comes later. So if we need a distinction between in and out. So we had in this one, we had that, and we need clock comment in, wait, yes, but this time it's 2 and 3. And 3, and that's B. So this is a different register. This is what we read on the open collector or open drain or whatever. Clock command in. We need to change that once we expand to the other in the other one to be able to write as well. Last clock idle. We need all that stuff here as well. Bus. Oh yeah, bus in. Okay, but we want to write now. So we assume state is idle. Present. This is something that we will do later. If bar state then we can send stuff. Can send, okay? And then we will try to send stuff, which will be here all loose with you. What do you mean? Your time value. Yeah, I am. It actually doesn't matter, I would say. The time value, the time value, unsigned int, yeah. But here, it might be if it would matter. Here, that's like just the lack of, these are like 16-bit values anyways. I'm working only with integer because it's the native muscle. Yeah, that's true. That's true. That's true. Yeah. This is just proof of concept. And you're getting obsessed again. Your eye is twitching. Oh no, he's using int and just a bit. Oh no, ah. I'll fix it later. Yeah. To do, make code J compatible. Okay, can send, and we will just send. If cute packet. Okay, if cute packet, we will do stuff. Okay, we will do stuff. Now, first of all, we will do static int, and now we have int clk out 1. This is by default. cmd out equals 1 and int data out and bus out equals, okay, here we go. Since we want to float it, yeah. I do the same with brackets most of the time. But that's just syntax, not semantics. Okay. I have many bad habits. Here we go. But this is not a code that is beautified yet. I will beautify my codes once I want to be. Since I'm what is it? How is it? ITIL in English. If this code will be uploaded, then I will make it nice. Or when I know then that works and I do a rewrite, and will be fine. I think I might do it even in C++. There's like, I would change this to C++ even before, but it's not so obvious. So you need, like, here, I can show you how that works. So if you do like a new file, new source file, yeah. So if I do like a main cpp, then the configuration of that isn't set yet, and that's like cumbersome every single time. We can even do it. Some people will hate it. They don't like. Okay, so we need to set RISC-V. Oh, you don't see anything. We make that smaller again. Small. Here we go. There's some configuration in doing first. So it's like out of the bag, C++ toolchain is not set up for that. And then you need to like clone also the includes. So I need to apply and close. I can't just change it to C++. I think I would need to change the properties as well for the compiler. So this, fortunately, I can copy all the lines at once here. Okay, so, but you have to know this. It took me some time to figure that out, because I don't know why people are obsessed using only C, as C is just, yeah, I remember the decision, okay. As C is for me just a subset of C++, and you're just missing cool features. And if and like logic operations are really awkward with C. It's like it wouldn't matter if you have like a single AND or double AND symbol there. It's just awkward without the Boolean type. Okay, so now it would compile properly, but and we can clone that contents there. I think we can do that now, since I have no. Charles meant that yeah, there is a new spec for C, but then like you have to have a compiler that supports like C 2012 or whatever specification, and it's like always a hassle. I don't want that. I want NC, C++. It's, oh shit. That might be NC. Yeah, there are a few things. I mean, there are so many features in C++ that are viable. I mean, even namespaces. If you don't want to use classes or virtual tables or whatever, because you really don't like for any memory waste or whatever, there is like you can still like just use like the parts that are really useful for developing and maintaining the code. So I don't know why we shouldn't use namespaces or something, especially on big projects. It's all fine using one header, just until you have like super long names of the variables and functions, which doesn't make sense at some point. You're just picking from a super long list instead of going down a tree. So I think it's viable for really like handleable projects. Microcontrollers probably are fine, but I don't know. Why limit artificially yourself to an inferior tool? Okay, I needed to switch that since the battery is almost empty. Okay, here we go. That was my rant on C and C++. Now we can do logic. Now I'm sure how the ifs work. Like a if and or not, then everything is clear. Okay, all right. We are sending a packet. So let's do cmd out. We pull it down. We also pull down the clock. We don't need to wait there. It's not like crucial to have like a half clock or whatever, or half phase, since it's just getting ready and it can be handled sequentially on the receiving side. So clock out is also down, and then we are starting to send. The buffer is owls. Oh. Okay. Okay, we prepared that should be prepared beforehand, or the packets should be prepared as bus data. I will just fill it right now as intermediate thing. So for defining stupid variables here in the middle of the for loop. Plus plus. Equals, we don't have the ID yet. And then we have the receiver. So I plus receiver ID. Yeah, that's true. That's true, and also like some abstraction is quite useful. I mean, you can work around stuff like you can use function pointers in C, but basically like Adafruit GFX library or my graphics library with the LED walls, where you have a map function. So I have like that was something that I was talking with someone who told me that he was inspired by my implementation of mapping the LED wall. So usually you have like the LED wall could be arranged in some sort of way, like a snake, like it's going left to right. That's one typical, if you have like a chain light or whatever. And then you can go from left to right, and then you have like segments, 8 by 8, which are going this way. So there is some sort of function how to map the complete X range and Y range onto channel, onto like segment and row and whatnot. And this is a simple implementation of the map function, which is an abstract virtual function and or whatever. If you implement like interface, which doesn't exist, like it's an abstract class, if you implement that, then you have like a very short code that just adds this map that is missing, and you know you have to implement it because otherwise the code won't compile. You have just to implement that, and everything is working after that. You don't need to, I mean, you can use like a function pointer. You can pass a function, and you have to know, oh, yeah, this function works like that. Okay, you have to also know how to implement the abstract function, but all right, I mean, it's kind of similar. Okay, bye-bye, Seth. Thanks. I will do a transmission. I like sometimes I like the and if you don't like virtual functions, it's basically ends up being the same assembly as C. You can even like optimize it for completely collapsing down everything if you have like const functions and const parameters and so on. I don't know to what extent that works with C already, but basically if you done a good implementation with classes as well, they can completely collapse into linear code, which is really cool. But that's also like compiler tech. I don't know. Okay, well, let's do receive ID. Okay, then we have the last one is, this is 16, will be 16 is length as equals, oops, which is basically 2, and then type. Oh, wait, yeah. So 0 is invalid. Funny thing. And this will be 1, or let's alternate it. Blink int, blink. Okay, blink, 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 blink. Every packet we send will be just blink plus plus, and yeah, blink and 1. Okay, so basically every packet will alternate between type 0 and type 1. This is like the, not type, this is the type. Okay, packet type. We can also define a new packet type, but on the receiving side we don't have implemented it yet. We will just alternate packets now. We need to find the ID. That should be simple. That's a function. But we have prepared our packets. We prepared our command line and clock line. We will send everything to, so we don't use time here. We use bus out, which with open range shouldn't do anything. Oh, this is cool. This is getting really cool. Clock out, command out, okay? This is what we do. With one write, we write everything to the bus. And then the bus should be prepared, which is then bus state prep, state prep pre-send. So bus state pre-send, and then we need, it will ignore collisions for now. This is something for later. It seems like a huge work here. Blink pattern, Mandelbrot shader. I don't believe we will finish that today. Okay, bus state pre-send, and then we need to clock out data. So CLK old. CLK out is this. Oh shit. Static CLK last C. Oh no, last CLK out. Ah, yeah, we need that as well. Last CLK in and out. We need to maintain both. I'm wondering if we should like separate the segments with read and write. It will be, read and write will be separated here somehow. Emote nuke, what? Yes, true. Last clock out is, let's say, 1. 1 is the last clock out. Okay, so when we start with packet, last clock out is basically 0. Last clock out is 0. And then, oh wait, we can set it here. We don't need to, it's basically, what? Weak attribute, I don't know that. Is this some kind of new specification? Weak attribute. See, okay. Virtual, but it's more. Okay. Another thing, like, I hate defines where you can basically use a const. Like a typed constant is way stronger than like preprocessor. Oh. There's a. Oh, okay. Yeah, okay. I never used before. I have to check. I have to check. I thought I knew the most of the stuff. Okay, CLK out. So we don't need like really to make a difference where it comes from. We know for the next round. So bus state idle, and now we have bus state. We know that we send something. Oh, we can already check the collision soon, my friends. Yeah, please give an example for weak. A short as possible example. Bus state pre-send. Oh wait, there is no pre-send. We can basically send after that. There is no pre-send. We can just send because there is no like lowering clock. We can ignore that and go just to send. So if that would be pre-send, okay, here, bus pre-send, then we would set clock out 0. Send, okay, this would be like clock out 0 and bus, but there is nothing bus state is equal bus state send. Okay, that would be the case, but we can basically remove that since it doesn't do any extra value. We can leave it in. Okay, if there is a use case for that, we can reactivate it. Replaced by the linker, okay. Wait, linker? Oh. Oh, okay. So basically, oh, yeah. So here's an example for one. Where does the attribute come? How the attribute, is this like an underscore? How is this defined? Attribute, something like that. Int min, int I, int b. No, it replaces stuff. Oh, okay. Oh, this way around. Okay. No, this is like a predefinition. It will, if you implement like, you're not sure if int min and max for int is implemented. If it's implemented somewhere, then take the other implementation, which is platform specific. If not, then use this generic one. This is what you mean. So basically, let's assume there is like, you have, let's say power or something, a math function like power, which can be implemented in a CPU, but you can implement a weak substitute for that if it's not like, but it should be implemented by the hardware abstraction layer. Okay, I get it. Or like vector functions, which can be implemented by the streaming functions of the x86, but not necessarily, and there is no like hardware abstraction generic function that is implemented by the compiler or whatever. Okay, I see a use case for that. Yes, that's like, that is similar to if not def blah then this, but this is like definition, not implementation. Okay. I see. Never used it. Okay, so boss. Today I learned stuff. TTL breaks if you don't have a Schmidt trigger. And there is a weak attribute. But I used it wrong. It is the brackets and you look at this. It's here. This is attribute. Ah, man, it's used here as well. And I found only code because I never used attributes before, and this is like a specific implementation of the wrapper of this interrupt. And it had like, you wrote it like the declaration with the attribute on this side, but the implementation has to have it in between the return type and this function name. So here, if it will be declared, then this whole contraption is on the right side, which is for me totally confusing. I have no clue why. And now this is here in between. This is how it compiles if you don't have predefined that, like declaration or in a header file or whatever. Okay, yeah, see that. Here we go. Good. We're sending stuff if last clock out. Yeah. Hey, bleep. Why are you up? It's like 1 o'clock in the morning. Or it's still like jet lagged from the weekend. if not last clock out, okay, if last clock out, then we have like idle state. We can double data. We can clock out data every single clock. That would be also cool. But for now, we just do CLK out equals. Oh, okay. When did your train go on Sunday? Okay, clock out equals 1. So in this case, we send data, which would pass index data out. We need to set it. Oh, really? Yeah, I took a train not long after you because so it was crazy. We were up until 5:55. This I don't know when you left, but like after the regular DJ from the time schedule stopped, there was like a playlist with random songs going on, like Spotify, and only like a few people were left dancing there way earlier. Okay. Yeah, so we were just dancing and then fighting over the playlist, which songs coming next. And then like around 4 o'clock in the morning, so it seems like people are living in this space. So the people that are renting or whatever, there were like people that were not from the maker community that were like roaming still in the space. And then another guy came with a turntable, like a digital turntable, and started doing like EDM sessions. And we just continued dancing and drinking. And it was like, I don't know, like really late. And then Brian left earlier than Alex and I. And at some point, I think at 5 or something, or 5. No, I know I was in bed 5:55. At 5, I think around that we left. I was too drunk to. Not that I'm proud of, but the wine and the spritz was tasty. And Alex had still a döner in the night. I couldn't eat at that time. I was like too, I don't know, groggy. And then we got up at, I think 9 or, no, wait, 10. Yeah. So it's like 4 hours later, we got up and I was still like dizzy. So I was still like drunk when I went back for the brunch. We had some brunch and then I noticed on my app that my train was cancelled as well, or my train in the evening was cancelled. It should go at 20:30. I still wanted to visit the gallery that you recommended to me, and maybe hang around a little bit with the people until the end. But yeah, there were still some lightning talks in the morning, which were really cool. I think it was like more relaxed than the lightning talks before that. There were way fewer people, maybe like let it be 25 or so people sitting there around and listening. So it was way more relaxed. And after the talks, there came some pizza and other stuff. And then I noticed like, okay, my train is cancelled, and I don't know when all the trains will be cancelled, and the last trains that will go in direction like south will be completely stuffed with people who want to get home. Because if I get stuck in Berlin, I probably will be relaxed, and at the end I will just cope with what's happening and stay in the X-Sign and relax and code a little bit, since I had a lot to tinker and with me. But I just immediately I grabbed some pizza and what was it, börek, and just went directly to the Hauptbahnhof and hopped on the next ICE and went home. So I was earlier at home. I was at home. No, I had to wait for Tony since she there was no bus going to the town where I live, because it's so small. There is no bus going there from. Yeah, the problem is that I have like a stuffed schedule. I need to finish stuff until the end of the month, which is in 2 days. And I really didn't want to like, and also like paying for another 2 nights of hotel or whatever. I could crash maybe a couch there, but it's like, if I didn't plan it, then I really don't want to like be stuck there. So Tony she wanted like to pick me up from the train station, but she was also like on a birthday on Sunday, and I arrived earlier than expected. Okay, bye, Ray. So I had like to wait for her on like the station. I went to like McDonald's or whatnot for 1 hour for her to arrive, and we could like go like grab the car, since only she had the car keys from the train station at home. But I was home at 8 o'clock. Yeah, that was chaos. Yeah, especially because I of course lost my seat reservation on the train, but it wasn't like I had like to move 2 times, and I found always a seat to like to sleep there, actually, because yeah, I sobered up in the train. But it was crazy. It was really fun. Unfortunately, I really sad that Sunday was basically cancelled. Yeah. And now we are programming this supercluster. Yeah, you had a flex ticket. My somehow stupid Deutsche Bahn didn't send me an email or changed my ticket or whatever. It was just they even. Yeah, yeah. Whatever. Next time maybe, but so far every time I went to Berlin, sometime every time was something wrong with the train. Either cancelled or whatever. Okay. Index out is 0, and then we start sending index out, huh? So clock out 1. Yes, or maybe revision in 1.5 weeks. No, I can't go there. I don't think I can go to revision again. Too much traveling recently, and I have no product to show for. Bus data out, bus index out plus plus. How many data? Oh yeah, oh, we don't know what the size is. The size is in that. Okay. We can find that out. Oh, you know what? They dismantled the mobilized couch. I think I could still crush on that couch. No, I actually sleeping is not allowed in this in Exine, but they dismantled the motorized couch. Actually, it's a regular couch again. Top. Oh, by the way, it's really cool. I met so many new people. These MCUs that I'm using for the cluster, the WCH, I got connected with one of the developers on that company, and I have now connections to the company that manufactures that ICs. I can get any samples, which is really cool, also of new ICs, and I managed to convince them so they will provide. So we still working on getting the really cheap ones on LCSC. Unfortunately, it's like there are some conflicts of interest, but JLC will receive a reel of those chips, and we can get a lot of things done. So I can manufacture more of these small devices. So here, there is the QFN version of that IC. It's cool. Purple LED, purple PCB. Yeah, so connections have been made as well, and a lot of new people met. Okay, we shifting out the bytes on the bus out, and then we check if bus index data out is whatever bigger or equal than bus data out. Which is this? Where is the size? Size is in 18? No, 16. 16 plus what? So 16 plus 2. This is where 16 is the length, and if we have 16, these are the IDs. So this is IDs. I should define like constants for that. That's like magic numbers now. We end the transmission here. Bus state will be freed from now on. Bus state equals bus state idle again, since we are done with sending stuff. Cool. Is that it? Wait, is this it? Oh no, it died. Warning, 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 warning. In. Last clock idle. Bus in. Clock idle. Last clock. No, this is all right. These are all the in. We are not reading yet. Okay, we're writing up. Wait. Is it working? No. This is the clock. We need still to reprogram. Oh yeah, not yeah. There are dev boards using that process. I own dev boards that are like not like small ones, but there are certainly some dev boards with that processor already. But this one here, at least the second version without the botch, might have USB at the end. We don't know yet. That's to be determined yet. Okay, we need to program the other one. So here we go. This is the, we not outputting LED clock, we outputting the packet bus state idle. Where's bus state? I don't know. LED bus state data. Yeah, okay, this is all right. So this should, oh, it might be cancelled. Oh shit, yeah, I need to, this is this debug interface. There are two interfaces, fortunately. This is way too slow. Ouch. Yeah, it's probably, the transmission is probably cancelled. Maybe, no, wait. Cancelled. Let's do it like that. We cancel it after the transmission is done here, and we never cancel it on idle. Okay? So we because we don't know yet how long that idle might be, how many clocks. And now we need to increase the clock of that, let's say to, oh, transmission was done. Oh. No. Oh. Yeah, that can't be. Something's wrong here. This is too fast. Hey, simple. Then, wait. How fast can we clock that? Ah. Okay. I'm doing this that fast right now. And now I will try to also change this clock speed to way fast. Wait, not as way faster as this was. How much faster is it? 48 times 3. 3 times faster. So that this is 2. So it needs to be at least 6 times 2, which will be 12. Let's do it just 10,000 hex here. Oh, that's what I said. Okay. Okay. Wait a minute. Don't tell me. Don't tell me. Oh, wagon loads. Yeah. No. There is. Yeah, this is, if you just joined, so you don't know what's happening, but we have like, I mean, we started with this, yeah. So this is like, we started to figure out, okay, this is like open collector, open drain bus design. That means that we have a pull up on each of the lines, and then we have like additional lines. One is clock line to just tell, okay, here is a new byte coming. And then we have a comment line which indicates, oh, there is someone starting a transmission, and the bytes are then coming on the bus. And this is like, this is okay, understandable. What's more difficult is when there is a collision on a bus, when two start at the same time. But at the end, it's not like super complicated if you go step by step. This is like, okay, code is always confusing if it's not your own code. But what we try to do is implement. Oh yeah, we have another node here. Yeah, okay, here. Here, this is basically the specification that we determined, like after thinking a little bit. So how the clock works, how the comment line works, and then how the sending works, payload size, payload, packet type, and this is now the better specification of the transmission. Then 8-bit sender unique ID, 8-bit receiver unique ID, and then packet start, size, packet type, and bytes, whatnot. And this is what we are doing right now. And what the blinking, currently we are misusing the packet type as blink or not, 1 and 0. And I'm not sure if this actually works or if this is a bug. So we're not even checking for collisions, and there is only one sender and all the other ones are receiving. But what we can try now, next, is we check for the unique ID, and I hope I can find I can find a unique, wait, this is not supercluster, user object peripheral. There must be a unique ID. I don't know how to read it, but there is a way. And what next next thing what we will do is just sending a byte and comparing if the byte is equal. Like, we will increase the byte that we send as packet type and compare it if it's equal to the last byte of the unique ID, and then we should see some LEDs light up and some not. That will be okay. I don't see. Wait, that's full. Where's, maybe it's not defined here. These are like the provided. What is IT? What is this? Conf? What is conf? Flash, OPA, USART, TIM, SPI, RCC, miscellaneous. Maybe miscellaneous here. Miscellaneous. Core. Oh, core RISC-V? No. What is that? That's the keys. Enable knob. I'm just looking for some get active, set priority. Where's the unique ID? Debug. Nah. What is LD now? That's the link. Include GPIO, miscellaneous. Okay, miscellaneous. What do we have here? Priority and big init, whatever this is like a, I have no clue what that is. OPA, SPI, RCC, watchdog. MK4? No. No, didn't see that yet. Is it as good as this one carbon printer that's so crazy fast and mad? They probably just needed to push out something to compete. I have to check it out. Is there a video? Is it what is so special about it? Is it small? Is it fast? Okay. Original Prusa. Oh, it's a kit? No. Not buying kit anymore. I hate kits. MK4. Okay. Effortlessly fast and silent, fully automatic first layer calibration, load sense, cell sensor, right off the box, extruder, custom break, smart features, what? Filament sensor, power, panic, quick swap nozzles, wide range materials, nylon, okay, flex and nylon. It's a direct drive printer, that's cool. Okay, but 900 bucks is for a kit is a high price nowadays. Okay, the screen looks okay. It's nice. Yeah. It looks like I need to check. I need to check the videos because it looks to me it looks like just an incremental upgrade to the MK3. Even though I don't have one. Which printer do you have? Probably Ender 3 or something. Which one are you using? Or do you have like the Prusa Mini, which is if I would buy a Prusa, then it would be probably the Mini because I don't want like huge printers anymore. Ain't nobody got time for that, printing huge stuff. MK2 still. Did you change like the driver, whatever? My MK2 is so loud and it's always like first layer is always off. I don't know what I'm doing wrong. Tron XY printers. Okay. Was it like a cheap, affordable solution or you know what? I recently received a longer printer for review, but somehow the first layers are squished. I'm not satisfied with the quality, and the only printer that's working right now is the ANET A4 for me. So I currently have only one working printer, which has flawless prints since the beginning, and that's the ANET A4. Who would guess? Yeah, okay. My spouse would complain all the time when I was running like the Prusa, especially if I let it run overnight or whatever. What's the cheapest aluminum frame? Okay. Okay, let me check if I can find the unique ID. It's probably just in a register somewhere. You need the ID SM bus. SM bus. Electronic signature. System storage area. Oh, okay, cool. Yeah. UID register. Wait, what is this? This is like, okay, yeah, 64 bits for the UID. 64 bits, UID is signature. Wait, there is even more. How long is this UID? Oh no. I thought the UID is 64 bits. Shit. Binary, oh no. This is too big. Let me check. Oh no. I have to change my protocol. Shit, that slows me down. It's 96. Oh no. Who knows which bytes? I thought this unique ID. Yeah, no. But I thought, where did I read that it is only 64-bit? 64-bit unique ID, security features. It says here in the datasheet. Why do I have... Okay, let me check. Extended config flash electronic signature. Is this the electronic signature feature? Datasheet. Security feature. I don't know what the security or signature. Okay. Byte options on flash memory. Security register flash. Maybe there's a different one. No, flash register. No. Address, select right. Boot key. What's this? Yeah, if I look for 64, I will find 1,000 occurrences. No. Okay, but let me check for that. It says, full. Maybe the first one of the IDs is like vendor or something specific. It doesn't say anything. UID. Okay, ASIC. Let's check the ASIC flag. That's unfortunate. It's the A signature. Maybe the function tells something else. SPI, OPA, how is this security feature? Signature. What is this? Prescaler. Power. Watchdog. Wait, is this peripheral? Object core. Let me search like this. Let's see if I can find any. No matches in workspace. Okay. Let's search signature. Nope. What the F? ASIC. Okay, ASIC. Must be. Designed. Oh, come on. Okay, let me hard code it here. Brute force method. A signature. What? It's not a register? It's called ASIC here. UID. UID. Doesn't say anything where this is located. What's the base address of this? What is going on? Dutch, you're still there. I check the examples. Maybe we will be able to find anything there. Okay. Pub example. Watchdogs, PI, RCC, OPA. Where do I don't know what this is. Nope. I'm really done, but I want at least to be sure that it receives data and blink and like that we can tell there is some sort of logic going on, not like everyone is doing the same thing, crunching numbers. It should at least like add two numbers or something. Add two numbers and blink out the thing. I don't know that we can do. I just want this stupid signature. Where is it? SP USART, Watchdog, RTC, Power, and EUP, Harmony, GPIO, Flash, Canvas, BLE. Okay. Everything is mapped to memory. Memory architecture. Factory cured and unmodifiable layers. Okay, you can see that's text. That's 64 bytes. User defined. Okay, so here are some registers, but this is not what I need a mapping. Okay, watchdog time reserved extend flash interface RCC DMA USART ADC port ABC XT flash. Vendor bytes, here, option bytes, vendor bytes. This is starting at this address. Okay, you know what? We can't get this from that one. Let me check the memory signature. E-signature. It also doesn't say anything. It has this unique ID. Okay. User option bytes. Okay, so the other one, this big one. Okay, thank you. Good luck yourselves. I think this configuration of this MCU is similar, and we can debug that one. So I'll be able maybe to, where's this memory map? Here. Vendor bytes, it's the same. Okay, so let's read the vendor bytes. since it seems to be like in that area and it's not specified, I don't know why. Something is missing there, but we can debug. Let's debug. Debug this IC. Oh. A signature. Wait, this is the wrong one. Back. Okay, this is the... We need to go to this one and debug that one. And then we will just check the memory, what it says there. Okay, open console, no, show. Memory. Okay, this is the memory that we want to see. Oh no, I have no clue. Where the unique ID starts and where it ends. Oh, I have a tool that I can test here. Okay, ahaha. MCU UID, and I can get information on that. Wait, wrong MCU selected. Here we go. BC5A, let's find it. Let's find it. This is what we are looking. Ah, BC, wait, isn't that here somewhere? No. BC, shit. That should be in the vendor space. Okay, we're looking for CD, oh no. Where is this? It's not there. Oh, it crashed. Memory crashed? No. These are the flash maps. Interestingly, the MCU ID only shows like 8 bytes. So some conflicting information here. BC and 5A. I need to try to BC 5A. This is the ID. BC 5A. C1 1B 2942. Okay, I found the ID. Okay, mates, this is the ID, and this is probably the upper 64 bits, which are basically nothing. So this is the address where it starts. 8B. Okay, fine. Oh, yeah. With the debugger, we can find it. So it starts at C8 1FF. This is crazy. 8 and then goes on for 8 bytes. Nice. Okay. Okay, we can work with that. We can work with that. Let's go. So answer you int 64T UID. Wait, you yeah. Stupid, but necessary. Theme 78, what is that? What's going on? Syntax. Oh, this stuff. Oh, I'm tired now. Shoot. I don't even know anymore how to cast. Okay. Oh, uint there. Yeah, it's embarrassing, but it's true. Okay, mates. Let's check what the UID is here. Oh yeah, we can debug now this, and then we should see the UID there. I will start the debugger again. Go to memory. Go to memory, and I will change this. Okay, delete that. And at 8 should start the UID, which is correct here. 8, yeah, E3. Wait, this is not the UID. What? Huh? Huh? What? Oh, it's E. VC. Oh, it's E8, not C8. Oh, thank God I checked that. Otherwise, we'd be... Okay, try again. Try again. Okay, now we got it. This is the unique ID. Okay, CDA, yes. Okay, cool. This is the unique ID, my friends. And now we will scan through the IDs. Oh, wait. Or close all tabs to the right. Very useful. And this is also the same for this, I believe. So if bus data, we will just check bus data 17 equals to UID UID as 255. Oh wait. Then let one else. Oh, let's toggle, but I don't know the last state. Okay, let's let toggle. We'll just toggle it by -1, which is funny. Okay. Oh wait, this is funny. Huh? GPIO out the R one. Lustig. It basically checks the last state and inverts it. Upsala. Okay. Just this is toggle. So if we didn't pass any state, it will -1, then it will determine it, invert it, and use this basically the same function. Sweet. Okay. So this code needs to be uploaded first, compiled and uploaded. So if packet type is last byte of, oh, unique ID. What is going on here? Oh no. No default parameters with, okay, let's add C++. Okay. Another reason to use C++, huh? And, oh, no, 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 no. I need some parameters first. Includes, what did I do? Okay, here. Okay, toolchain, RISC-V settings includes this. Okay, this can be, okay, okay. Yeah, okay. What? Oh, wait, what? Do I need to re-edit? Tool chains, foo. Let's just leave the empty. I have no nerves to try it. Oh shit. Could add this as C++ when I select source for, okay. Main C, I don't know why it really needs that. Zero warnings. What is going on? Okay. Apparently we are warning free. First try. Unbelievable. So this will be uploaded. Okay. Okay. Apparently there is no MCU with 0 or 1 in the last digit. Now, okay, we can remove that. Now we go back to the main MCU and cycle through the data out 17, which is basically blink N255. And at some point there should be some MCU that will be triggered. Every 256. Yeah. Write it down. Uh-oh. Oh, we need to wait. No, this is taking too long. It should be one should be already turned on already. Is the toggle not working? It was too perfect. you're smart, huh? Okay, clock seems to be clocking. Yeah, clock is working. Okay, data. Shoot. Wait. We have that. We can check. Okay, there is even more blinking on that one. That's whenever a new packet starts. But it should really increase. Blink. Wait, is blink even? No, blink is here. Plus. 17. What is the other ones testing? 17. Oh, wow, this will be hard to debug now. Okay, I can debug this here. Let me debug this one here and see what happens. Okay. Okay, that one cycles. Wait a second. Oh, I see an error. I never stop set low bus idle state, bus send. Oh yes, that's why I left it here. Okay, clock out is still 1. Okay, bus state send. Now we switch from send to low. Okay, here. Yeah. I think we need to set clock comment out high again. Yeah, I'm still going, but actually state present. I don't know if that helps. Just switching from present like clock. Yeah, going down. Okay, let's leave it like that. The data might be just misaligned. Where's the error? Oh yeah, here. No. We should see whenever we are here, blink plus plus, comment out. Should be high. Adam, yeah, I'm still going. But just to see, I'm not able to debug the 16 ones. Otherwise, I would be able to see what's happening there. Unfortunately, I didn't test it. I can try to debug it, but there will be like 16 CPUs. Yeah, I mean, oh yes, it's hard. We have defined stuff like that, the protocol, everything is defined, but not implemented. That's what we are doing right now. And blink pattern or com test, that's basically happening, everything is happening at once. That's the list is like flawed in that case. Oh, why is this low? Did I destroy the LED? I hope not. High, 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 high. Yeah. Oh yeah, you're right. Okay. We can check it here. Idle. Okay, whenever it's done. This one should be low. Okay. Ah. Comment out is 0. Oh, wait. We switch to that, we switch to that, and we switch to that. That's not good. We change the bus state. We need to else, because that's bad. Okay, that's bad programming. Okay, bus state. We still need, we might want like to optimize that still away, but I think this should be all right now. Okay, I need to fix that, because we are switching from that to that to that instantly, which never will be picked up by this here. Okay, let me check. Nothing is lighting up. No, none of the 16 is coming. Okay, I need to debug it. So I need to check if the bus state, so at this point, LED should be on, then it should be off, then should be on again, like that. Maybe even here. No, wait, clock out. Last clock out, okay. Let's try. Still not receiving. Not sure where it fails. Maybe even at the first byte, and it canceled for some reason. So if we don't receive, like, if there is like a misalignment, then we can wait for the data however we however we want. We'll never receive like anything else. Then okay, anything else then. Okay, bytes. Done. State send, off, on, and go. You go. Okay. Now I need to debug the other ones. I can try to debug 16 at once. I don't know what happens with the one-wire interface if we try to do that. Let me get them here. It's the debug wire. Let's go here. And let me check if we need to bus state receive, not clock. State pre-receive. Else, I should be checking like this here, because I have no control of what was last. If I have bus state pre-receive, then I should wait until this happens before I switch to receive. So like we have at least a prepare clock. It's a little bit confusing, but okay, it programmed. Now F comment. Okay. Ah. Oh shit. I mean, they have all the same stuff running. I don't know what's happening right now. Wow. I don't know who is answering, but someone's answering and they're all ending up at the same position. This will, oh, you know what? I want to check the memory, if I can read the memory at, yeah. Look at this. We have the unique ID, and this is BA is the last ID. I wonder if we do like, how many bytes do we receive? Wait. Okay. Let's do that. Oh no! Oh no! I restarted it. Oh. What does it do? Oh. Oh, issue. Yeah. Oh, no. It died. Okay. Debug signal issue. Okay, that's... Oh, maybe it supports only one breakpoint. And JTAG is really messed up trying to single step or whatnot it's using. Okay, let's try again. Oh, by the way, what is our memory saying? Hex, yeah. BA, no, it's still the same. Bus state receive. Okay. 0, 1. Wait. 83. What did it send with 83? Oh, it's probably, oh no, it's, we can't single step here. Oh no. Okay, you know what we can do? We can breakpoint in here. When we know we should receive all the data. Okay, here is what we received. 80. What is that? What is that data here? Okay, you can see, but this is not good data at all. This is like, what is this trash? It should be all 0, but 17 should be something else. This is not what we... Zero, 17. It's almost. It's almost. Look at that. It's almost there. Oh no. 17. It does something with the 17. But it's so random. It looks like we get We should do it one by one. First changing. We entered the matrix. Wait, what happened to my audio? I can't hear you anymore. Why is it not 0? It's byte 16. Oh wait, it shouldn't be. It's 2 bytes. Wait. It was correct. Yeah, it's 2 bytes. Okay. I'll show you. We receive stuff. It's correct. Okay, here we receive stuff. 2 bytes of data. This data and this data. This is correct. 2 and that, and everything else is 0. Okay. We are receiving correct data. Now, the problem is with switching LED, probably. I don't know if this is read-only or write or whatever. What? Oh, yeah, that one here. Doesn't ever compare to LED. Okay, different story. We should do something else. We should do something else instead of that. That will never be entered. Okay. What is the UID here? I don't know if that even works with this long. Let me try something else. UID. uint 8. And then we just take, this will be an array, and we just take the first byte, okay? How about that? Yeah, I'm still going. Ugh. Okay, I need to debug that. Apparently, it seems that I'm even able to. Okay, let me record that for my video. Apparently, I'm able to debug all the MCUs at once, and I don't know which one responds. It seems to be. Let me check that since I have memory. It's always BA at the end. I don't know. This is the ID. BA2517. Okay. This is now C++. 66. Wait. Two, 5. Is it always 2, 5? Yeah, this is always 2, 5. 95, and this is cycling. So why don't we end up in here? We never end up in here. Data is transferred. We entered it. Wait. Oh no. Oh, you know what? That might be like of all the IDs, like the last digit might be not very unique. That's why we need so long to cycle through all the IDs. Okay, let me just run it. Okay, like that. We just run it and we see if it ends up being receiving this ID at some point. It should toggle. I hope it toggles. Let it run, let it run. Or, you know what? Oh, yes. They have all the same last byte. Okay. Let's compare it to and once we get like another 200 packets sent, once we have next to 200 packets sent, it should just turn off again. Yes, okay, it works. Now let's pick a better ID. Pick a better byte of the ID, because that seems to be similar and it might be, we need to take byte. Okay, if we take byte 7 of the ID, that should be, let's program it and see if it's still so not unique. Oh wait, compiling first. Here we go. Come on. No. Where's the uniqueness in this ID? Okay, let me check. At the end, they all have the same ID. Oh, okay. That, Okay, friends. And then it should turn off again. This is the unique byte. Oh, it turned off, and here we go. Okay, it's transferring correctly. Now, oh, here it comes. Ah, yes! Okay, unique ID works and transferring data works. I can check off some stuff of my list here. Cool. So let's do it while it's running in the background. Because we use a parallel bus and there is no master and no slave at the end, it will be like a super fancy, I don't know, yeah, it could be. I2C also supports some kind of interrupts. Okay, open collector bus works because, oh yeah, we are using only one end of the open collector, but handshake, we didn't, but the protocol somewhat we tested communication. We have not implemented all the, and we have a blink pattern. I think we implemented a few things today. Now collision detection and handshake. Okay, this is cool. This is really cool. Here it comes. Peeps, here it comes. Ah, yeah. Oh. Quad bus? What is that? Cool, cool, cool. Oh, that's cool. Okay. This is the unique part. This byte is the unique byte. Yeah, it's just, but it's slow. Should we try to increase the speed? Should we amplify it? I don't think we can do way faster than. Oh wait. Data out clock. More speed. I'm not sure if we can increase the clock any further here on that one. I can try to go to 400. Okay, this is like we have not like a lot of cycles to process everything. Yeah, that's what's happening. Okay, and now I need to increase that protocol, which needs to be 4 times that. That will be 1000. Okay, so let's make that faster. Okay, we increase it by I don't know if that will work. It might work, but what? Okay, we increased the speed, my friends, of this protocol. This one is funny. I don't know where this ID comes from, but cool, cool. Oh, nice. One struggler. Yeah, it's not struggling. It has just a completely different ID. But that seems like one of the sequential bytes of the ID. I'm comparing only one byte of the 8 bytes, and it seems like they're not. Some might turn on at the same time, but it looks like quite sequential, and this one is totally off. Funny. Okay. Oh, I think I'm done for today. I'm sorry, guys. Oh shit, it's 2:30. Oh no! Okay, good night. I need some sleep. It's a brother from another mother. What? Okay. Oh. Okay, thanks everyone for joining the stream. 6 godzin. Okay. Thanks everyone for joining. Yeah, apparently it takes time to develop a new protocol. Yeah, but I'm satisfied so far. Now we need... No, no, yeah. Good night, everyone. Yeah, yeah. We found we did some research today. So we found out TTL can break. Yeah, TTL can break unique ID address. We found that even though it's not specified in the API. We somewhat reinvented the wheel regarding the open collector bus, and that's about it, huh? Okay. Good night, everyone. Schmidt, yeah, Schmidt trigger saves our life. Oh wow, the stream is so behind here in this window. Okay, bye bye. Sleep well.